build system in Maven. Now we are focusing on build system. Maven builds a project using its project object model, POM, and a set of plugins. Here you can see an overview of Maven build elements. Here the gray colored rectangles are provided by you, and green colored rectangles green colored rectangles are provided by Maven, and the pink colored rectangle shaded is the output, the deployment artifacts from your project. These custom plugins are optional. The rest of the inputs are mandatory. And here you can see project object model POM, pom.xml, and repository, local or remote, are connected to Maven build system. Maven plugins are connected to Maven build system. Custom plugins are connected to Maven build system. Maven build system is connected to project artifacts, and this is output. Here you can see Maven here you can see the library is connected to pom.xml, and Java source code is connected. Pom.xml is connected to Java source code and other assets, and project is connected to Maven, and Maven interacts with Maven local repository and more Maven remote repository, and Maven is connected to compile, test, and package, and that is connected to deploy. With regarding benefits of Maven, consistent build. Maven promotes consistency in build process across different projects. This helps maintaining standardized development environment, leading to fewer configuration issues. Automated testing with Maven built-in support for testing. Developers can easily run unit tests, generate reports, and integrate testing into the build process. Project documentation. Maven can automatically generate project documentation, including Java docs and reports, making it easier for developers to understand and use the code base. Continuous integration. Maven is often used in CI/CD, continuous integration, continuous deployment pipelines. CI tools like Jenkins, Travis CI, and GitLab CI can be configured to trigger Maven builds whenever changes are pushed to the version control. Code quality analysis. Maven can be integrated with code analysis tools like SonarQube or FindBugs to ensure code quality and identify potential issues in the code base. Project reporting. Maven generate various reports such as test reports, code coverage reports, and project documentation, making it easier for developers and stakeholders to track project progress and identify areas for improvement. Managing project profiles. Maven supports the use of profiles to handle different build configurations such as development, testing, and production. This feature allows developers to manage build setting for different environments efficiently. Here you can see how the Maven works. To start using Maven, developers need to install it on their system and create a POM for their project. Once the POM is set up, and they can use Maven commands like Maven clean install or Maven test to execute various build phases. Integration with IDEs. Most modern integrated development environments, IDEs like Eclipse and IntelliJ IDEA have built-in support for Maven, making it seamless to import Maven projects and leverage its features within the IDE. Plugin ecosystem. Maven has a rich plugin ecosystem, allowing developers to extend its functionality and integrate with other tools, making it a flexible choice for various project requirements. Servlet library and another Java library is connected to pom.xml. Spring library is connected to pom.xml. Spring library, here the Spring library and Servlet library and another Java libraries are connected to pom.xml. And here the step 2, another Spring library, Servlet library and another Java library are connected to Java source code via import. Here the Java source code and pom.xml are in the Java project. Here the Java project is connected to compile and build, and compile here then compile and build interacts with Maven install and build. And 5, the pom.xml is connected to Maven install and build. The 6, the Maven repository local is connected to Maven install and build via install, and 7, Maven repository online is connected to download to Maven via download and install. The 8, the compile and build is connected to Java apps. Here the Maven repository local, here the Windows C colon for /users username /m2 in Unix /home your username /.m2. Here the online Maven repository online is http://mavenrepository.com. Here you can see the Maven release process. The 3 build life cycles of Maven are clean up the artifact that are created by prior builds. Default build used to create the application site for the project generates site documentation. Here is a nice diagram which to explain the Maven build and release cycle. Here the developer, here the 2.0 snapshot is connected to CVS via check-in code. Here the 2 release prepare 2.0 snapshot is connected to CVS and 2.0 via update POMs, and 3 compile and test. Here the update then release prepare 2.0 snapshot is connected to CVS via tagging release and check-in POMs. Then 2.0 is connected to 2.1 snapshot via update POMs and then compile and test. Then 2.1 snapshot is connected to CVS via 7 via check-in POMs. Then CVS is connected to 2.0 via checkout text code. Here the 2.0 is connected to Nexus via 2.0 release via compile, test, and then deploy artifact release perform here. And here the 11 CV is connected to is 2.1 snapshot via check out POMs to the developer. Here this 2.0 snapshot, 2.0 and 2.1 snapshot and Nexus are in Maven. Here the packaging For example, the jar packaging will bind the following goals to build phases of the default lifecycle. The most common way is to set the packaging for your project via the equally named POM element packaging. Some of the valid packaging values are jar, var, EAR, and POM. If no packaging value has been specified, it will default to jar. Each packaging contains a list of goals to bind particular phase. For example, the jar packaging will bind the following goals. To build phases of the default lifecycle. This is an almost standard set of binding. However, some packaging handle them differently. For example, a project that is purely metadata packaging via value is POM. Only binds goals to the install and deploy. Install and deploy phases. For a complete list of goals to build phase bindings of some of the packaging types. Note that for some packaging types to be available, you may also need to include the particular plugin in the build section of your POM. Specify extensions true for the plugin. One example of plugin that require this is Plexus plugin, which provide Plexus application and Plexus service packaging. Here you can see the phase, and here you can see the goal plugin, goal for the jar packaging. Here process resources, and compile. Here compile. Process test resources and test resources here. Test compile, here compile, test compile. Test, surefire test, package, jar, install, and deploy. Here you can see clean lifecycle. Here the pre-clean execute processes needed prior to the actual project cleaning. Clean, remove all files generated by the previous build, and post clean, execute processes needed to finalize the project cleaning, and these are phases. Here you can see the phases of default lifecycle. Validate the project is correct and all necessary information is available. Initialize build state, for example, set properties or create directories. Generate sources, generate any source code for inclusion in compilation. Process sources, process the source code, for example, to filter any values. Generate resources, generate the resources for inclusion in the package. Process resources, copy and process the resources into the destination directory ready for packaging. Compile the resource source of the project. Process classes, post-process the generated files from the compilation, for example, to do bytecode enhance on the Java classes. Generate test cases, test sources, generate any test source code for inclusion in the compilation. Process test sources, process the test source code, for example, to filter any values. Generate test source resources, create resources for testing. Process test resources, copy and process the resource into the test destination directory. Test compile, compile the test source code into the test destination directory. Process test classes, post process the generated files from the test compilation, for example, to do bytecode enhancement on Java classes. Run test using a suitable unit testing framework. These tests should not require the code be packaged or deployed. Pre-package, perform any operation necessary to prepare the package before actual packaging. This is often result in unpacked processed version of the package. Take the compiled code and package it in its distributed format such as jar. Pre-integration test, perform any actions required before integration tests are executed. This may involve things such as setting up the required environment. Integration test, process and deploy the package if necessary into an environment where integration tests can be run. Post-integration test, perform actions required for after integration tests have been executed. This may including clean up the environment, verify, run any checks to verify package is valid and meets quality criteria, install the package into the local repository for use as a dependency in other project locally. Deploy done in an integration or release environment, copies the final package to the remote repository for sharing with other developers and projects. Here you can see the phases: validate, install, generate resources, process resources, generate resources, process resources, compile, process classes, generate test class sources, process test sources, generate test resources, process test resources, test compile, process test classes, test, prepare package, pre-integration test, integration test, post-integration test, verify, install, and deploy. Here you can see clean lifecycle bindings. Here the phase and plugin. Here the clean and binding is plugin goal is clean. Here you can see default lifecycle bindings, packaging, EJB3, Java, Era, and WA. These are the phases and plugin goals. Process resources, then plugin goal is resources, compile, process test resources, test resources, test compile, test compile, test, surefire test, package, EJB or EJB3 or Ja or Pa or Arara or Wawa, install, deploy. So here you can see the default lifecycle bindings for packaging EAR. Here the phases, and these are the plugin goals. Generate resources, EAR generate application.xml, process resources, package EAR, install, deploy. Here you can see the default lifecycle bindings for packaging Maven plugin. Here you can see the phases, and here the goals. Generate resources, plugin descriptor, process resources, compile, process test resources, test compile, test compile, test, surefire test, package, jar, plugin, add packaging, add plugin artifact metadata, install, deploy. Here you can see default lifecycle. Default lifecycle is defined with phases without any associated plugin binding. Plugin bind for the life cycles are defined separately for each packaging. Here you can see the phases: validate, initialized, generate resources, process resources, generate resources, process resources. Generate sources, process sources, generate resources, process resources, compile, process classes, generate test sources, process test sources, generate test sources, process test sources, test compile, process test classes, test, prepare package, pre-integration test, post-integration test, verify, install, and deploy. Here you can see clean lifecycle. Clean lifecycle phases are defined within their plugin bindings. Here pre-clean, clean, and post-clean. So here you can see the Maven clean plugin. Here you can see wrapper lifecycle here. Wrapper lifecycle phase defined within their plugin bindings. Here wrapper, and here the Maven wrapper plugin. Here the plugin bindings for default lifecycle reference. Here you can see the plugin bindings for jar packaging. Here you can see the Maven resource plugin resources, and this is plugin version. Maven compiler plugin compile, Maven resource plugin test resources, Maven compiler plugin test compile, Maven surefire plugin test, Maven jar plugin jar, Maven install plugin install, and Maven deploy plugin deploy. Here you can see plugin bindings for EJB packaging. Here you can see Maven resource plugin resources, Maven compile plugin compile, Maven resource plugin, test resources, Maven compile plugin test compile, Maven sure plugin test, Maven EJB plugin EJB, Maven install plugin install, Maven deploy plugin deploy. Here you can see Maven plugin in the Maven plugin bindings for default lifecycle reference in the plugin bindings for Maven plugin packaging. Here you can see Maven resource plugin resources, Maven compile plugin compile, Maven plugin descriptor, Maven resource plugin test resources, Maven compile plugin test compile, Maven surefire plugin test, Maven jar plugin jar, Maven plugin add plugin artifact metadata, Maven install plugin install, Maven deploy plugin deploy. Here you can see plugin bindings for default lifecycle reference, plugin bindings for var packaging. Here the Maven resource plugin resources, Maven compile plugin compile, Maven resource plugin test resources, Maven compile plugin test compile, Maven surefire plugin test, Maven var plugin var, Maven install plugin install, Maven deploy plugin deploy. Here you can see plugin bindings default lifecycle reference, plugin bindings ER packaging. You can see Maven ER plugin generate application XML, Maven resource plugin resources, Maven ER plugin ER, Maven install plugin install, Maven deploy plugin deploy. Here you can see the plugin binding for default lifecycle reference, the plugin binding for RAW package. Here Maven resource plugin resources, Maven compile plugin compile, Maven resource plugin test resources, Maven compile plugin test compile, Maven surefire plugin test, Maven RAW plugin RAW, Maven install plugin install, Maven deploy plugin deploy. Here you can have here the phases and plugin goals. Here the when we run Maven package, MEN package in the Java project, plugins that are plugged into phases are shown in this figure. Lifecycle phases don't come with any functionality to carry out tasks. They really rely on plugins. For example, compile plugin doesn't actually compile the Java source. It's sort of a delegated job to compile. Goal of Maven compile plugin, which invokes the rusty old Java C to compile the project. When the lifecycle phase is executed, Maven builds specific plugin goals to lifecycle phases depending on the Maven on the project and packaging type. For example, when we run Maven package in Java project, the plugins that are plugged into phases are as shown in this figure. To compile phase, Maven builds compile goal of the Maven compile plugin. Similarly, test phase, it binds test goal of Maven surefire plugin. So on. What happened at package phase is a bit interesting. In a Java project, Maven binds Java goal of Maven Java plugin. However, when we run the same command in web app project, Maven binds var goal of the Maven var plugin. Which plugin and goals bind to the phases depend on project and also package, var, Java, etc. type. Here you can see lifecycle phases and here plugin goals. Here process resources is interacts with this resources. Here compile interacts with compile. Here process classes, process test resources interacts with resources, test resources, test compile interacts with compiler, test interacts with surefire test, prepare package interacts with jar. Here the lifecycle phases, process resource compile, process classes, process test resource, test compile, test, prepare package. Here the plugin goals, resources, compile, resources test resource, compiler test compile, surefire test, jar. The default lifecycle has the following build phases. The validate, validate the project is correct and all necessary information is available. To compile, compile the source code of the project. Test the test the compiled source code using a suitable test unit testing framework. These tests should not require the code be packaged or deployed. Package, take the compiled code and package it in its distributable format such as jar. Integration test, process and deploy the package if necessary to an environment where integration test can be run. Verify, run any checks to verify the package is valid and meet the quality criteria. Install the package into local repository for use as a dependency in other projects locally. Deploy, done in the integration or release the environment, copies the final package to the remote repository for sharing with other developers and the project. These lifecycle phases plus the other lifecycle phases not shown here are executed sequentially to complete the default lifecycle. Here you can see lifecycle phases, here plugins, this is POM, and here the machine is connected to Maven. Here the machine is connected to compile via Maven compile, and here the generate sources, and here the compile is Maven compiles. Machine is connected to compile via Maven compile, and Maven compile is connected to here compiler. The compile goal, test compile here. Here test compile is connected to compiler here, test compile goal here. Here test is connected to surefire test goal here, and here machine is connected to a Maven test, connected to the package via MVN test, and here the integration test and install is connected to jar via jar goal, and install goal via POM. Here Maven MVN install is connected to deploy, and here the POM is here. This connectivity is going through POM, and these are the plugins: archetype, compiler, surefire, jar, and install. Here the plugins define goals. Goals can be bound to phases. Goals from multiple plugins can be bound to single phase. Maven is a plugin execution framework. Plugins are an assembly of goals, code written as mojos. Maven plain old Java project objects. Modern mojos are not restricted to being written in Java. Goals have names and can be bound to phases. A mojo declares its goal name and optionally a phase associated with which binds the class to a part of a life cycle. Plugins is typically a .jar file which contains the mojo classes and meta-ina/maven plugin.xml. This plugin.xml is generated as a part of the Maven execution of the plugin code. Plugin 1 is one interacts with goals here, and other plugins are also interacts with goals mojo here. It has a name and phase here. Here the phase 1, phase 3 here, again phase 1 here. So goals mojos are connected to phases here. Phase 1 here. This goal is see the plugin 1 goal is connected to this interact with this goal, and this goal is connected to phase 1, and here plugin 3 interact with this goal, and this goal is connected to phase 1. Here the plugin 2 interact with this goal, and this goal is connected to phase 3. This is a life cycle, and these are the phases: phase 1, phase 2, phase 3, and these are plugins, and these are life cycle. Here you can see the association between life cycle and phases, life cycle phases, goals, and plugins. Maven goals are granular and typically perform one task. Multiple goals need to be executed in an ordinary fashion. to perform complex operations such as generating artifact or documentation. Maven simplifies these complex operations via lifecycle and phase abstractions, such as build-related operations could be computed with a handful of commands. Maven build lifecycle constitutes a series of stages that are executed in the same order, independent of artifact being produced. Maven refers to the stages in a lifecycle as phases. Every Maven project has the following three built-in lifecycles. Default, this lifecycle handles the compiling, packaging, and deployment of Maven project. Clean, this lifecycle handles the deletion of temporary files and generated artifact from the target directory. Site, this lifecycle handles the generation of documentation and site generation. To better understand the build lifecycle and its phases, let's look at some of the phases associated with the default lifecycle. Validate runs checks to ensure that the project is correct and all dependencies are downloadable and available. Compiles the source code. Test runs test unit run unit testing using frameworks. This step doesn't require that the application be packaged. Assembles the compiled code into a distributed format such as Java. Install the package archive into local repository. The archive is now available for use by any project running on that machine. Deploy pushes the build archive into a remote repository for use by other teams and team members. Maven lifecycle is an abstract concept and can't be directly executed. Instead, you execute one or more phases. For example, the command mun package will execute the package phase of the default lifecycle. In addition to clearly defining the ordering of phases in a lifecycle, Maven also automatically executes all the phases prior to the requested phase. So when mun package command is run, Maven will run all prior to phases such as compiled and test. A number of tasks needed to be performed in each phase. For that to happen, each phase is associated with 0 or more goals. The phase simply delegates those tasks to its associated goals. This figure shows the association between lifecycle, phases, goals, and plugin. It is valid for a Maven phase to have phase not have any goals associated with it. In that case, Maven will skip the phase execution. Such phases serves as placeholders for users and third-party vendors to associate their custom built goals. Here you can see the phases are in life cycle. Here the phases are phase 1 is connected to phase 2, phase 2 is connected to phase 3, phase 3 is connected to phase 4, phase 4 is connected to phase 5, phase 6 is connected to 5 is connected to phase 6. Here the phase 2 is connected to goal A, and here the and plugging and his goal B, and phase 4 is connected to goal C and plugging 2, and here the phase 6 is connected to goal D in plugging 3. Plugin goal D interacts with plugin 3. In other words, phase 1 is connected to phase 2 here. Phase 2 is connected to goal A and then and goal B, and here these goals are interacts with plugin 1. Phase 2 is connected to phase 3, and phase 3 is connected to phase 4. Phase 4 is connected to goal C, and that interacts with plugin 2. Here phase 4 is connected to phase 5, phase 5 is connected to phase 6, phase 6 interacts with goal D, and that connected to goal D, and that interacts with plugin 3. Now here you can see default lifecycle for VAR project. The packaging element in pom.xml will automatically assign the right goals to each of the phases without any additional configuration. Remember that this is a benefit of COC. For example, if the packaging element is jar, then the package phase will be bound to jar goal in the jar plugin. Similarly, for the var artifact, pom.xml will bind the package to var goal in the var plugin. This figure shows the portion of the internal life cycle associated with the VAR project. When you run the package phase, the test phase is also run, and all the unit tests get executed. If there are any failures in the test phase, the build fails. This is the described desired behavior. However, there are times, for example, when dealing with legacy project, where you would like to skip compiling and running test, so you can build the project successfully. You can achieve this using maven.test.skip property. Here the project resources is connected to resources, and it actually interacts with resources, and project resources is connected to compile is connected to compile, it actually interacts with compiler. Compile is connected to test, test is connected to surefire interacts with test is connected to package is connected to var is interacts with var. Package is connected to install is connected to install interact with install is connected to deploy is connected to deploy, and deploy interact with deploy. Here you can see how to build Maven lifecycle. Sequence of steps which is defined in order to execute the task and goals of any Maven project is known as build lifecycle. Maven 2.0 version is basically a build lifecycle oriented and clearly says that these steps are well defined to get desired output after successful execution of the build lifecycle. Here you can see the POM section and dependency manager and lifecycle here. Here the pom.xml is connected to here the pom.xml is in the POM. Here manager plugins and dependency are in dependency manager, repositories in dependency manager and POM. Here the compile, test and install are in lifecycle. Here pom.xml is connected to manager is connected to project information, dependencies and plugin, and those are connected to repositories. The dependencies and plugins are connected to the repositories, and repositories are connected to plugins and dependencies. Here for example, here this plugin is connected to compile and test, and this plugin is connected to install. Here you can see a high-level diagram that tries to show how Maven build life cycles, phases, plugins, and goals interact between each other. Here you can see the life cycles. Here default, clean, and site are in life cycles. Here the default phases, compile, test, install, etc., and clean phases, pre-clean, clean, post-clean. Site phases, feed site, post site deploy are in phases. Here the plugin clean, plugin compiler, and other plugins are in plugins and goals. And here goal clean in plugin clean. Here goal compile in compiler. Here goals are in other plugins. Here the default is connected to default, clean, and site are connected to phases. Here the default is you can see the default phase here, and here the clean phase here, and site phases default phases are here, and clean phases are here, and site phases are here. The phases are connected to plugins goals here. As an example, we can consider this. Here's an overview of the top elements under settings. The settings element in the settings .xml file contains elements used to define values which configure Maven execution in various ways, like pom.xml, but should not be bundled to any specific project or distributed to an audience. These include values such as local repository location, alternative remote repository servers, and authentication information. So this is in settings.xml file. Now we are considering simple values. Half of the top level settings elements are simple values representing a range of values which describe elements of the build system that are active full time. Here local repository, this value this value is the path of this build system local repository. The default value is $use open braces user.home closing brace /.m2 /repository. This element is especially useful for a main build server, allowing all logged in users to build from a common local repository. Interactive mode, true if Maven should attempt to interact with the user for input, false if not. Default is default to true. Offline, true if this build system should operate in offline mode. Default to false. This element is useful for build servers which cannot connect to a remote repository, either because of network setup or security reasons. As an example 3, we can consider this. Invalid repository exception. Class invalid repository exception signals an error when adding a repository to the model resolver. This is in package org.apache.maven.model.resolution. Here you can see a building Maven. Here we are considering a class build in package org.apache.maven.pi.model. The build element contains information required to build the project. Default values are defined in superpump. That is related to API. Here the why would I want to build Maven? Here the in building Maven or a plugin or any component yourself is for one of two reasons. To try out bleeding edge features, so bug fix issues can be found in Jira. To fix a problem you are having and submit a patch to the developers team. Now we are considering checking out resources. All of the source code for Maven and its related libraries are managed in the ASF source code repositories. Now we are considering building a Maven plugin or component is like any Maven build. In building a Maven plugin or component in building Maven. Here you can see the command, and here running integration test before submitting a patch. It is advised to run the integration test which are available in the run here the run-its profile. Now we are considering building Maven core. To do this, run from the source directory. Until Maven 3.3, the Maven core build could be bootstrapped with any ent build. This bootstrap has been removed from in Maven 3.5. You need the pre-built Maven to build the Maven from source. To do this, run from the source directory. The assembles will be created in Apache Maven and can be manually unzipped to the location where you like the resulting Maven installed. If you want to have the resulting Maven directly copied to a directory, you can use the distribution target dir property here. Running the full Maven core integration test before checking in a change or submitting a patch to Maven core, it is required to run the core integration test using your local build of Maven. Run this one. Now we are considering build lifecycle basics in introduction to the life cycle. The build lifecycle is made up of phases. For example, the default lifecycle comprises of the following phases. For the complete list of lifecycle phases, refer the lifecycle reference. Each of the build lifecycles are defined by different list of build phases, wherein a build phase represents a stage in the life cycle. For example, the default life cycle comprises of the following phases. For the complete list of the life cycle phases, refer the life cycle references. Validate the project is correct and all necessary information is available. Compile the source code of the project. Test the compiled source code using suitable unit test framework. These tests should not require the code to be packaged or deployed. Package, take the compiled code and package it in distributable formats such as jar. Verify, run the checks on the result of the integration test to ensure quality criteria is met. Install the package into the local repository for use as a dependency in other project locally. Deploy done in the build environment. Copies the final package to the remote repository for sharing with other developers and projects. These lifecycle phases plus other lifecycle phases not shown here are executed sequentially to complete the default lifecycle. Given the lifecycle phases above here, this means that when the default lifecycle is used, Maven will first validate the project, then try to compile the sources, run those against the tests, package the binaries, for example jar, run integration test against the package, verify the integration test, install the verified package to the local repository, deploy the installed package to a remote repository. Now we are considering usual command line calls. If you are uncertain what you want, the preferred phase to call is this one. You should select the phase that matches your outcome. If you want your jar, run package. If you want to run the unit test, run test. If you are uncertain what you want, the preferred phase is called preferred phase to call is this one, verify. This command execute each default lifecycle phase in order to validate, compile and package etc. before executing verify. You only need to call the last build phase to be executed, in this case verify. The most cases the effect is the same as the package. However, in the case where the integration test, these will be executed as well. And during the verify phase, some additional checks can be done. For example, if your code written according to the predefined live check style rules. In the build environment, use the following call to build and deploy artifact into the shared repository. The same command can be used in a multi-module scenario, that is a project with one or more sub-projects. Maven traverses into every sub-project and execute clean, then execute deploy, including all the prior build phase steps. Now we are considering plugins. Plugins in setting up your project to use build lifecycle. So to use the Modello plugin and have it generate sources from a Modello on a model and incorporate that into the build, you would add the following to your POM and in the plugins section of the build. You can use packaging. That's the common way to set packaging. Set the packaging for your project in the life cycle. And second way is to add goals to phases is to configure plugins in your project. Plugins are artifacts that provide goals to Maven. Furthermore, a plugin may have one or more goals wherein each goal represents a capability of that plugin. For example, a compiler plugin has two goals, compile and test compile. The former compiles the source code of your main code, and while the latter compiles the source code of your test code. As you will see, the plugins can contain information that indicates which lifecycle phase to bind to the goal to. Note that adding the plugin on its own is not enough information. You must specify goals you want to run as part of your build. Goals that are configured will be added in the goals already bound to the lifecycle from the packaging selected. If more than one goal is bound to the particular phase, the order is used. To indicate that those packaging are executed first, following by those configured in the POM. Note that you can use the executions element to gain the more control over the order of particular goals. For example, the Mojo plugin binds by default. For example, the Modello plugins by default its goal modello.java to the generate sources phase. Note the Modello Java goal generates Java source code. So to use Modello plugin and have it generate sources from a model and then incorporate that into build, you would add the following to your POM in the plugin section of the build. You might wonder why executions element is there. That is so you can run the same goal multiple times with different configurations. If needed, separate executions can then be can also be given an ID, so that during inheritance and application of profiles you can control whether goals configuration is merged or turned into an additional execution. When multiple executions are given that match a particular phase, they are executed in the order specified in the POM with inherited execution running first. Note in the case of Modello Java, it's only makes sense the generate sources phase, but some goals can be used more than one phase, and there may not be a sensible default. For those, you can specify the phase yourself. For example, let's say you have a goal display time that echoes the current time to the command line, and you want it to run process test resources phase to indicate when the tests are started. This would be configured like so here. Then an example we can consider this one. Actually, this is a warning. Some problems were encountered while building an effective settings. Unrecognized tag, build, position, start tag, start underscore tag seen in activation, etc. and build at /home/guest /m2/settings.xml line 16 column 13. This is occurred during the command mun clean install. Now we are focusing on pom.xml. A project model or POM is the fundamental unit of work in Maven. It is an XML file that contains information about the project and configuration details used by Maven to build the project. It contains default values for most projects. Examples for this is the build directory, which is a target, source directory, which is src/main/java, the test source directory, which is src/test.test/java, and so on. When executing a task or goal, Maven looks for the POM in the current directory. It reads the POM, gets the needed configuration information, then executes the goal. Here you can see POM overview. Here the asterisk element with asterisk element may be overridden, at least mostly, by profile element settings. And elements with here elements with double asterisk profile elements are the asterisk dash suffixed elements. Here this sign contains elements for meant inheritance. Maven projects dependencies, builds, artifacts, all of these are objects to be modeled and described. These objects are described by an XML file called a project object model. The POM tells Maven what sort of project it is dealing with and how to modify default behavior to generate output from source. In the same way, a Java web application has a web.xml that describes, configures, and customizes the application. A Maven project is defined by presence of pom.xml. It is a descriptive declaration of a project Maven. It is the figurative map that Maven needs to understand what it is looking at when it builds your project. You can also think of pom.xml as an analogous to Makefile or an ant build.xml. When you are using GNU Make to build something like MySQL, you will usually have a file named Makefile that contains explicit instruction for building a binary from source. When you are using Apache Ant, you likely have the file named build.xml that contains explicit instruction for cleaning, compiling, packaging, and deploying an application. Make, Ant, and Maven are similar in that they rely on presence of a commonly named file such as Makefile, build.xml, or pom.xml, but that is where the similarities end. If you look at Maven pom.xml, the majority of POM is going to deal with descriptions. Where is the source code? Where are the resources? what is the packaging. uh, if you look at an ant build.xml file, you will see something entirely different. You will see explicit instructions for tasks such as compiling a set of Java classes. The Maven POM is declarative, and although you can certainly choose to include some procedural customizations via the Maven Ant plugin, for the most part you will not need to get into gritty procedural details of the build if your project's built. POM is also not specific to building Java projects. While most of the while Maven default plugins are targeted at building jar artifacts from a set of source, test, and resources, there's nothing preventing you from defining a POM for a project that contains C# resources and produces some proprietary Microsoft binary using Microsoft tools. We have established that the POM describes and declares. It is unlike an ant or make in that it doesn't provide explicit instructions, and we have noted that POM concepts are not specific to Java. Here you can see the project object model and overview. POM contains 4 categories of description and configuration. The general project information. This includes a project name, the URL for a project, sponsoring organization, a list of developers and contributors, along with your project, along with your contributors, along with the license for a project. In build settings, in this section we customize the behavior of the default Maven build. We can change the location of sources and sets and tests. We can add new plugins. We can attach plugins goals to the lifecycle, and we can customize the site generating parameters. Build environment. The build environment consists of profiles that can be activated for use in different environments. For example, during development, you may want to deploy to a development server, whereas in production you want to deploy to a production server. The build environment customizes the build settings for specific environments. and is often supplemented by custom settings.xml in title /.m2, and POM relationships. A project rarely stand alone. It depends on other projects, inherits POM settings from parent projects, defines its own coordinates, and may include submodules. And if we reconsider this, POM stands for Project Object Model. It is an XML representation of a Maven project held in a file named pom.xml. When in the presence of Maven folks, speaking of a project is speaking the philosophical sense beyond a mere collection of files containing code. A project contains configurable files as well as the developers involved and roles that they play, and the defect tracking system, the organization and licenses, the URL of where project lives, the project dependencies, and all of other little pieces that come into play to give code life. It is a one-stop shop for all things concerning the project. In fact, in Maven world, a project does not need to contain any code at all, merely a pom.xml. The POM contains all necessary information about the project as well as configurations of plugins to be used during the build process. It is declarative manifestation of who, what, and where, while build cycle is the when and how. That is not to say that POM cannot affect the flow of the life cycle. It can. For example, by configuring Maven-Antran plugin, one can embed Apache and task inside the POM. It is merely a declaration, however, whereas a build.xml tells and precisely what to do when it is run procedural. The POM states its configuration declarative. This the external force causes the lifecycle to skip the ANT plugin execution. It does not stop the plugin that are executed from doing their magic. This is unlike a build.xml file, whereas tasks are almost always dependent on the lines executed before. Here, Maven coordinates. The POM defined above is the bare minimum. Here group ID artifact ID version group ID artifact ID version group ID artifact ID version are all required fields. All the group ID and version do not need to be explicitly defined if they are inherited from a parent. These three fields act much like an address and timestamp in one. This makes a project place in a repository act like a coordinate system for Maven projects. Project ID, this is generally unique amongst an organization or a project. For example, all core Maven artifact should live under the group ID org.apache.maven. Group IDs do not necessarily use the dot notation. For example, the JUnit project. Note that the .-noted group ID does not have to correspond to package structure that the project contains. It is, however, a good practice to follow. When stored within a repository, the group acts much like the Java packaging structure does in an operating system. The dots are replaced by OS-specific directory separators such as / in Unix, which becomes a relative directory structure. from the base repository. Artifact ID. The artifact ID is generally the name that the project is known by, although the group ID is important. People within the group will rarely mention the group ID in discussion. It along with the group ID creates a key that separates this project from every other project in the world. At least it should. Along with the group ID, the artifact ID fully defines the artifact's living quarters within the repository. As an example, my dash project lives in $m2 underscore repo /org /codehouse /mojo /my project version. This is the last piece of the naming puzzle. Group ID : artifact ID denotes a single project. But they cannot delineate which incarnation of the project that we are talking about. Do we want JUnit : JUnit of 2008 version 4.12 or of 2007 version 3.8.2? In short, code changes. Those changes should be versioned. In this element keeps those versions in line. It is also used within an artifact repository to separate versions from each other. For example, my dash project version 1.0 files live in the directory structure $m2 underscore repo /org /codehouse /mojo my project /1.0. These three elements given here to a specific version of the project here, letting Maven know who we are dealing with and when it's in its software life cycle we want them. With regarding packaging, now that we have our address structure of group ID : artifact ID : version, there is one more standard label to give us a really complete what, that is project packaging. For example, pom4 org.codehouse.mojo my dash project 1.0 define can be packaged as a jar. We could make it into WAR by declaring a different packaging. When no packaging is declared, Maven assumes the packaging is default jar. POM relationships. The most powerful aspect of Maven is its handling of project relationships. This includes dependencies and transitive dependencies, inheritance, and aggregation. Multi-module projects. Dependency management has a long tradition of being a complicated mesh for anything but the most trivial of project. Jarmageddon quickly ensures as a dependency tree become a large and complicated. Jar hell follows, where versions of dependencies on one system are not equivalent to the versions developed either by wrong version given or conflicting versions between similarly named jars. Maven solves both problems through a common local repository from which to link projects correctly, versions and all. Dependencies, the cornerstone of POM is its dependency list. Most projects depends on others to build and run correctly. If Maven does for you, this is if all Maven does for you is manage this list, you will gain a lot. Maven download and links the dependencies on compilation as well as on other goals that require them. As an added bonus, Maven brings in the dependencies of all those dependencies, transitive dependencies, allowing your list to focus solely on dependencies that your project requires. One of inheritance, one powerful addition that Maven brings to build management is concept of project inheritance. Although in build systems such as Ant, inheritance can be simulated, Maven makes project inheritance explicit in the project object model. And the super POM, similar to inheritance of the objects in object-oriented programming, POMs that extend parents POM inherits certain values from the that parent. Moreover, just as Java objects ultimately inherits from java.lang.object, all project object models inherits from a base super POM. Dependency management. Beside inheriting certain top-level elements, parents have elements to configure values for child POMs and transitive dependencies. One of these elements is dependency management. It is used by POMs to help manage dependency information across all of its children. If my-parent project uses dependency management to define a dependency on JUnit: 4.12, then POMs inheriting from this one can set their dependency giving the group ID equal JUnit and artifact ID equal JUnit only, and Maven will fill the version set by the parent. The benefit of this method are obvious. Dependency details can be set in one central location which propagate to all inheriting POMs. Aggregation or multi-module. A project with modules known as a multi-module or aggregator project. Modules are projects that this POM lists and executed as a group. A POM package projects may aggregate the build of a set of projects by listing them as modules, which are relative path to directories or POM files of those projects. Properties are the last required piece to understand POM basics. Maven properties are value placeholders like properties in Ant. Their values are accessible anywhere within a POM by using the notation $, open curly brace, close curly brace, where X is the property, or they can be used by plugins as default values. And in this diagram you can see properties here. Build settings. Beyond the basics of POM given before, given here, there are two more elements that must understood before claiming basic competency of the POM. They are built element that handles things like declaring your project's directory structure and managing plugins, and reporting elements that largely mirrors the built element for reporting purposes. The built, according to the POM 4.0.0 XSD, the built element is conceptually divided into two parts. There is a base build type, which contains the set of elements common to both built elements, the top level built element and the project, and the built element and the profiles covered profiles. There is a build type which contains base build set as well as more elements on for the top level definition. The basic built element set. Base build is exactly as it sounds, the base set of elements between the two built element in the POM. Resources, another set of built element, is specifying where resources exist within your project. Resources are not usually code. They are not compiled, but are items meant to be bundled within your project or used for various other reasons such as code generation. Plugins, beyond the standard coordinate of group ID : artifact ID : version, there are elements which configure the plugins or this build interaction with. Plugin management is an element that is seen along side plugins. Plugin management contains plugin element in which the same way, except that rather than configuring plugin information for this particular project build, it is intended to configure project builds that inherit from this one. However, this only configured plugins that are actually referred within the plugin element in the children or the current POM. The children have every right to override plugin management element definitions. The build element set, the build type in the XSD denotes those elements that are available for the project build despite the number of extra elements. 6. There are really only two groups of elements that project build contains that are missing from the project from the profile build: directories and extensions. Directories, the set of directory element live within the parent built element, which set various directory structures for the POM as a whole. Since they do not exist in profile build, these cannot be altered by profiles. Extensions are a list of artifacts that are to be used in this build. They will be included in the running build class path. They can enable extensions to build process, such as add an FTP provider for the Maven transport mechanisms, as well as make plugins active which make changes to the build lifecycle. In short, extensions are artifacts that are activated during build. The extensions do not have to actually do anything for contain mojo. For this reason, extensions are excellent for specifying one out of multiple implementation of common plugin interface. Reporting contains the elements that correspond especially for the site generation phase. Certain Maven plugins generate reports defined and configured under report element. For example, generating Javadoc reports. Much like the built element's ability to configure plugins, reporting commands the same ability. The glaring difference is that rather than fine-grained control of plugin goals within the executions block, reporting configures goals within report set elements. An subtler difference is that a plugin configuration under the reporting element works as a built plugin configuration. Although the opposite is not true, a built plugin configuration does not affect a report plugin. Report sets. It is important to keep in mind that an individual plugin may have multiple goals. Each goal may have separate configuration. Report sets configure execution of a report plugins goals that does this familiar deja vu. The same thing was said about build's execution element, with one difference: you cannot bind a report to another page. Sorry. Here you can see more project information. Several elements do not affect the build, but rather document the project for the convenience of developers. Many of these elements are used to fill in project details when generating the project's website. However, like all POM declarations, plugins can use them for anything. Followings are the simplest element: name, description, URL, inception. Here, name. Project tend to have conventional names beyond the artifact ID. The Sun engineers did not refer to their project as Java-1.5, but rather just called it Tiger. Here is where to set that value. Description, a short human readable description of the project. Although this should not replace formal documentation, a quick comment to any readers of the POM is always helpful. URL, the project's homepage. Inception year, the year the project was first created. Licenses are legal documents defining how and when a project or parts of a project may be used. A project should list licenses that apply directly to this project, and not list licenses that apply to the project's dependencies. Organization. The most projects are run by some sort of organization, business, private group, etc. Here is where the most basic information is set. Developers. All projects consist of files that were created at some time by a person. Like other systems that surround a project, so to do this, people involved with a project have a stake in the project. Developers are presumably members of the project's co-development. Note that although an organization may have many developers, programmers as members, it is not good form to list them all as developers, but only those who are immediately responsible for the code. A good rule of thumb is, if the person should not contacted about the project, they do not need to be listed here. Contributors are like developers, yet play an auxiliary role in a project's lifecycle. Perhaps the contributor sent in a bug fix or added some important information. A healthy open source project will like to have more contributors than developers. In the environment settings, in the issue management, this define the defect tracking system, Bugzilla, TestTrack, ClearQuest, etc. used. Although there is nothing stopping a plugin from using this information for something, it's primarily used for generating project documentation. Continuous integration management. Continuous integration build system based upon triggers and timings such as hourly or daily have grown in favor over manual builds in the past few years. As build systems have become more standardized, so have the systems that trigger those builds. Although the majority of configuration is up to the specific program used, continuum, cruise control, etc., there are a few configurations which may take place within the POM. Maven has captured a few of recurring settings within a set of notifier elements. A notifier is a manner in which people are notified of a certain build status. Mailing lists. Mailing lists are a great tool for keeping in touch with people about project. Most mailing lists are for developers and uses SCM, the software configuration management, so-called the source code control management, or succinctly version control, is an integral part of any healthy project. If your Maven project uses a SCM system, it does, doesn't it? Then here is where you place that information into POM. Prerequisites. POM may have certain prerequisites in order to execute correctly. The only element that exists as prerequisite in POM 4.0.0 is the Maven element, which takes a minimum version number. Repositories. Repositories are collection of artifacts which adhere to Maven repository directory layout. In order to be a Maven repository artifact, the POM file must live within the structure $base underscore repo / group ID / artifact ID / version / artifact ID - version.pom. $base underscore repo can be local file structure or remote base URL. The remaining layout will be same. Repositories exist as a place to collect and store artifact. Whenever a project has a dependency upon an artifact, Maven will first attempt to use a local copy of the specified artifact. If that artifact does not exist in the local repository, it will then attempt to download from the remote repository. The repository element within a POM specify those alternate repositories to search. Plugging repositories are home to two major types of artifact. The first are artifacts that are used as dependencies of other artifacts. These are the majority of artifacts that reside within central. The other type of artifacts is plugins. Maven plugins are themselves a special type of artifacts. Because of this, plugin repositories may be separated from other repositories, although I have yet to hear a convincing argument for doing so. In any case, the structure of plugin repositories element block is similar to the repositories element. The plugin repository element each specify a remote location where Maven can find new plugins. Distribution management. Distribution management act precisely as it sounds. It manages the distribution of the artifact and supporting file generated throughout the build process, starting with the last element first. Repository. Whereas the repositories element is specified in the POM the location and manner in which Maven may download remote artifact for use by current project. Distribution management specifies where and how this project will get a remote repository when it is deployed. Repository element will be used as for snapshot distribution if the snapshot repository is not defined. Site distribution. More than distribution to the repository, distribution management is responsible for defining how to deploy the project site and documentation. And relocation projects are not static; they are living things. A common thing that happen as project grow is that they are focused to move more suitable quarters. For example, when your next widely successful open source project moves under the Apache umbrella, it would be good to give users a heads up that the project is being renamed to org.apache.my-project:1.0. Besides specifying new address, it is good form to provide message explaining why. Profiles. a new feature of POM 4.0 is the ability of a project to change settings depending on the environment where it is being built. A profile element contains both an optional activation, a profile trigger, and a set of changes to be made to the POM. If that profile has been activated, for example, a project built for test environment may point to a different database than that of the final deployment, or dependencies may be pulled from different repositories based upon JDK version used. The element of profiles are there. Activations are the key of the profile. Power of profile comes from its ability to modify the basic POM only under certain circumstances. Those circumstances are specified via an activating element. The base built element set, if we revisited, the reasons for two types of built element reside in fact that that does not make sense for a profile to configure built directories and extension as it does in the top level of a POM. Regardless of in which environment the project is built, some values will remain constant, such as directory structure of a source code. If you find your project needing to keep two sets of code for different environments, it may be prudent to investigate refactoring project into two or more separate projects. Here you can see POM, and you can see POM relationships. Under that you can see coordinates. Under that you can see group ID, artifact ID, and version. You can see on aggregation, and you can see modules under that, and you can see inheritance under POM relationships. Here you can see parents, dependency management, and under dependencies you can see dependency management and dependencies. Here you can see project information under POM, and you can see name, description, URL, inception year, licenses, developers, contributors, and organization under project information. Here you can see build system under POM, and you can see properties, packaging, build, and reporting under build system. Here you can see build environment under POM, and you can see environment information, Maven, and Maven environment under build environment. You can see issue management, CI management, mailing list, and SCM under environment information. And you can see pre-request, repositories, distribution management, profiles under Maven environment. And you can see repositories, plugin repositories, and repositories and plugin repositories under repositories. And you can see profile under profiles, and activation and suffix elements under profile. Here you can see element may be overridden at least mostly by profile element settings. Here modules, dependency management, build, reporting, repositories, plugin repositories, distribution management, and profile elements that are the asterisk dash suffix element here under profile. These are the element contains element meant for inheritance. Here you can see dependency management and build. Here you can see the super POM is always the base parent. The super POM all Maven projects POMs extend the super POM, which defines a set of defaults shared by all projects. The super POM is a part of Maven installation. Depending on the Maven version, it can be found in the maven-x.y.z- etc.jar or maven-model-builder.xy.z.jar file in $ open curly brace m2 underscore home close curly brace / lib. If you look in this jar file, you will find a file named pom-4.0.0.xml under the org.apache.maven.model package. It is also published on the Maven reference site that is available on each version of Maven separately, and for example Maven 3.1.1, it can be found on the Maven model builder documentation. Here you can see inherit from. So com.company.killerapp-stores 1.0-snapshot is inherit from here, and com.mycompany killer app-api 1.0-snapshot and com.mycompany killer app-model 1.0-snapshot are inherit from these three inherit from com.mycompany killer app 1.0-snapshot, and this is this inherits from superpom here. Here you can see the default lifecycle bindings packaging pom. Here you can see the phases and the plugin goals here, this package, and install, deploy. Here you can see the plugin bindings for packaging. Here you can see the Maven install plugin install and Maven deploy plugin deploy. Here you can see this diagram shows what is pom. Here you can see the pom.xml here. Pom or project object model is the basic unit of Maven. Pom is actually an XML file that contains all the configuration and information which is useful to build the Maven project. Inside pom, the configurations which are specified are nothing but the dependencies and goals that can be executed. You can specify some other information as well inside pom, like project version, developers, mailing list, etc. Here you can see the pom.xml here, and here you can see the pom project object model is connected to pom, and here project object model interacts with dependency manager. Dependency manager is connected to repositories, and project object model and dependency manager interacts with project lifecycle. Project lifecycle interacts with plugins. Plugins interacts with source code, generated code, resources, binary files. Sorry, actually plugins are connected to source code, generated code, resources, and binary files. Here you can see the advantages. Here the main advantage of pom.xml are when you declare the required dependency inside the pom.xml, then the Maven download all the required dependencies in the form of a jar. It will be available to to Java class path in Eclipse IDE, for example. You can also add new libraries to projects. You don't have to search anywhere to download the files. Maven automatically download all the required files for the given version from the Maven central repository. It can work in IDEs, in the CI servers, as well as on the command line. Here you can see Maven reads, step 1 reads pom.xml. Then the download dependencies into the local local repository. 3 the execute life cycles, build phases and or goals. Then executes plugins, all execute according to the selected build profile. Here you can see Maven is connected to POM file via reads pom.xml. Within the POM you can see build life cycles. It has goals and phases and goals, and dependencies, jars, build plugin and build profiles. Dependencies, jars are connected to Maven local repository. Here you can see the visual of plugin element. The types of plugin, broadly plugins are of 2 types. Build plugins configured in a POM for project POM under the build element. Such plugins are executed as part of the default build lifecycle. Reporting plugins configured as the project POMs under reporting element. Such plugins are executed as part of the site lifecycle. Furthermore, plugins can be classified as core plugins where goals are bound to the core phases. Clean, compile, install resources, etc. Packaging plugins related to output artifact packaging. Examples include plugins EAR, Java, etc. Reporting plugins related to the site lifecycle and used to generate reports. Examples include check style, Javadoc, project info, reports, etc. Tooling plugins related to general tooling during the Maven execution. Examples include assembly help, enforcer, tools chain, etc. Plugin from Maven versus custom plugins. The official Maven plugins developed as part of the Apache Maven have standard naming convention. Plugin short name plugin. This naming convention is reserved should not be used by plugins which do not have a group ID of org.apache.maven.plugins and are not found on the Maven repository under org/apache/maven/plugins directory. Plugins developed with other group IDs typically have the name of plugin short name -maven -plugin. Standard plugins from Apache Maven have consistent site structure under common site https maven.apache.org plugins index then .html. Each plugin landing page has a few menu items under its navigation panel. Introduction page which provide an overview of the plugin. The goals page which lists all goals defined by the plugin and a deep explanation of goals intent. The usage page provides configuration options and any relevant information regarding constraint for the plugin. An FAQ page is for responses for frequently asked questions. There are additional pages for license and download of the plugin as well. In addition to the standard menu items, the plugin landing page can provide links to examples and project documentation. The plugin site is the best way to start understanding plugin provided by Apache Maven. Plugins developed by external to Apache Maven should attempt to follow the similar conventions to ensure easier implementation by users. How to use plugins in the project POM. The plugins are configured in POM under either build or the reporting or the profiles, then profile element. The plugin can be located using standard Maven GAV group artifact version coordinates. In addition to the location coordinates, the plugin has few other elements that are optional. Extensions, the extension flag to an extension The extensions is a flag to determine if Maven extensions from the plugin should be loaded. The value is true or false. However, the current data type in the schema is a string for some technical reasons. The default value is the false, and it is rarely enabled. Typical use cases for enabling this is when defining custom lifecycle or packaging types. Inherited is a boolean flag that is true by default. As with extension, the data type in the schema is a string. Setting inherited to false prevent propagation of the configuration to any child POM of the current one. Executions. The execution is a complex element and contains set of execution elements. As its core, Maven executes such definitions. The execution specifies the set of goals to execute defining during the life cycle. The execution is a complex element that has a unique ID, phase, a phase to bind, and one or more goals to an inherited flag, similar to the one defined for a plugin, and also set as a string data type. The goals element, which is set a string goal element that are bound to the phase, and the generic configuration element. Dependencies is a complex element and contains a set of dependency elements. The dependency defines the listed the dependency elements. Configuration is a complex element which allows for a free form DOM configuration used by the plugin. Configuration specified specifics are typically listed and recommended in case of custom plugins in the usage page for a given plugin. Plugin inheritance. Plugins have inheritance logic similar to dependencies. A plugin declared in a parent POM is inherited into the child POM unless the parent declared inheritance flag to false. Setting the inheritance flags to false break the inheritance. In addition, the plugin management section in the POM functions the same way of dependency management works for a dependency. There's currently no equivalent in a build of materials for a plugin, although there is an open source issue for introducing such facility. Mixing Maven plugin, not officially an Apache Maven plugin, but the mixing -Maven plugin deserved a special mention. The plugin allows for including multiple plugin management sections without needing to inherit the plugins from a single parent. Using this plugin allows a build behavior to be made more modular. Here you can see the Maven POM plugins. Here you can see group ID, artifact ID, version, extensions, and inherited. Here the executions, and under execution and execution is there, and under execution ID, pace, inheritors, and goals, and configuration. Under goals you can see goal. Here you can see dependencies and configuration. Here we are considering how does Maven assemble the effective POM. An effective POM is an assembly of execution steps, properties, and profiles. The content that match that Maven can execute for a project, and an exhaustive set of dependencies and plugins needed for such an execution. Determination of any transitive dependencies of independencies, full depth imaginable, any conflict resolution in terms of dependency version. How does Maven assemble the effective POM? Maven assemble its effective POM by traversing the layers that act as building blocks. Each layer used has the ability to override or enrich the content of what become the effective POM. Maven internal defaults and super POMs are built built into the Maven installation, so ideally not subject to customization. The layers below the global settings And user settings are, as their name suggests, inclined towards the hosting and overriding any settings for Maven. The parent bill of material and project pumps are where Maven instructions can be customized. Default values above the layers are utilized if no customization is made. Now we are going to explain the layers. They're going through the layers here. Maven internal defaults. This layer is within the Maven's own code unless the intent is to modify the Maven source code. It is safe to assume that the default are not modifiable. The location is internal to the Maven installation. Maven superpom. This superpom exists in the Maven own code. Once again, unless the intent is to modify Maven's own source code, it is same to assume that the superpom is not modifiable. Location is internal to the Maven installation. Maven global settings. The Maven one Maven is installed or unarchived on a computing device. It creates a directory structure. One of these base directories listed base directories is conf. This directory contains settings.xml referred to as global settings file. Since this file extent exists on the local computing device, it is editable. Typically, any settings that apply to all projects being managed on the computing device are managed in this global settings.xml. Examples may include proxy settings, corporate server URLs, mirrors, etc. It should not often be modified in any case. Location is in Unix and Mac OS. Maven installation /conf/settings.xml. In Windows, Maven installation /conf and /settings.xml. Maven user settings similar to global settings, but at a different location. It is possible to create a user settings file. This file is also named settings.xml, but it is its location is under user home in an .m2 directory. The purpose of the user settings.xml is to set up any settings that apply to projects managed by a specific user. There could be multiple users on a given computing device. Examples include the usernames and passwords to connect to network, repository ordering, etc. Locations, Unix or Mac OS, user.home /m2./settings.xml. In Windows, user.home for /m2/settings.xml. Parent or build of materials pumps. Maven has an inheritance and version trait model. Maven can inherit content from and version traits from a build of materials POM. Typically, parent POMs contain reusable dependencies, plugins, and properties used by a project POM. The build of material POM is a specialized POM that allows group together dependency versions of dependency that are known to be valid and tested to work together. Using BOM POM reduces the developer grief from having to test compatibility of different dependencies. Modification of either is possible if there is a need and entitlement to change. Since changes to either can impact several other projects, appropriate version increment and reviews are recommended for changes. The locations is various locations either on device or elsewhere in some repository. Project POM, this is the project object model for the project. Project specifies specific Maven instructions are detailed in this location. Typical content include a unique set of coordinates used to identify the project name and description of the project, a set of developers associated with the project, any source control management details specific to the project, all project specific dependencies and plugins, any profiles that allow for alternative executions of Maven on this project, and so on. All this will be covered in the file containing this POM is by convention named pom.xml, but other names can be used. If an alternative name is used, then the Maven executable will need to be pointed to the file name of for the execution. The location Unix or Mac $project pom.xml. In Windows, $project / pom.xml. Here you can see effective pom here, and here you can see Maven internal default. Each lower section overrides the prior values. Maven super pom, base pom, all other poms inherited this pom. Maven global settings located in the conf directory under the Maven installation directory. Maven user settings located in the .m2 directory under the user home directory. Parent or bill of materials poms, inheritance and trait structure for project poms to inherit from. Maven project pom, content of the project pom, and here you can see effective pom. Here you can see hierarchies, pom hierarchies. Here we are going to describe the hierarchy of Maven poms. Parent pom. The parent pom is a pom from which the current project pom can be inherited. For the project current pom can inherit content. The project pom can depend on exactly one parent pom. This single parent inheritance is one way. The parent pom is unaware of the poms that inherit from it. Here. The single parent inheritance is one way. The parent pom is unaware of the pom that inherits from it. The child pom declares the parentage in its own pom.xml. The standard file to hold the pom can be customized to a different name. Any number of poms can declare another pom as their parent. Usage, while we will delve into the content in the future. The parent pom can be used to declare reusable portions of the pom that individual child pom can inherit. This helps in both maintenance and to reduce clutter. Aggregator pom. The aggregator pom, also known as reactor pom, that can sequence the build of many projects. An aggregator pom specifies all the projects that can be built, managed together. The child poms, remain unaware of the aggregator poms that invoke it. A child pom can be listed in more than one aggregator poms. The aggregator poms list the child pom by name in its own pom.xml as a module. As the declared module suggests, this pattern is for modular builds of projects. There is no inheritance of any content from the aggregator pom. Usage, while the aggregator pom can be used to ensure the sequence of build and maintain a list of projects that should be built, managed together. Build of materials pom. Build of materials pom is a pom that can declare bundles of dependencies that have been tested to work well together. The abundance of artifacts and versions of each can at times lead to confusion and needs for trial and error mechanism to determine compatibility or might right functionality. A build of material poms reduces that overhead. Build of material pom is a means of multiple inheritance too. Since a project pom can import multi example build of material pumps. The build of material pumps is unaware of the child pumps that import it. The child pumps declare the build of material in the project pump. Usage the while this will the build of material pumps can be used to bundle well working dependencies with right versions together to avoid repetition for every project. The POM can be both parent as well as aggregator. This allows for a two-way relationship in a tightly knit set of modules that depends on a common set of inheritance content. Here you can see POM hierarchies. Here you can see percentage. Yeah. Here the parent is connected to another parent. Parent POM is connected to another parent POM via dependencies, plugins, properties, and another parent POM is connected to here the project POM via dependencies, plugins, and properties. Here the child knows the parent, and parent doesn't know the child. Here you can see the aggregation. Here the aggregate POM is interact with the POM. Here the POM 1, project 1 POM, project 2 POM, project 3 POM, and project 4 POM via no inheritance of contents. The child does not know aggregator, and aggregator knows child. Here you can see the build of materials. Here the build of materials POM is connected to project 1 POM, project 2 POM, project 3 POM, project 4 POM. Likewise, the project POMs via dependencies, plugins, and properties. Here the child knows build of Here the child knows build of materials. The build of materials does not know the child. Here we are considering transitive dependencies. With direct dependencies, the things you use yourself in your own code for the own code, and transitive dependencies things so here in the direct dependency, things you use yourself in your own code. For the transitive dependencies, things others use for things you use, pulled in recursively. Here you can see that your code is connected to direct dependency A, direct dependencies. Here the A and B, and here the direct or transitive dependency Z, and here the direct dependency B is connected to direct or transitive dependency Z. Here your code then direct dependency B is connected to direct or transitive dependency Z. Here the direct dependency is connected to transitive dependency TA and TB, and here the transitive dependency TB and direct dependency B is connected to transitive dependency TC. Now we are considering bill of materials BOM. Larger projects like Payakara, Amazon, SDK, etc. provide list of direct dependencies. This comes in handy when adding these dependencies transitive for us as a direct dependencies like here. Here you can see your POM, and your POM is connected to your POM inherits Maven super POM, and your POM import is connected to some BOM via import. and some BOM is depend on direct and transitive dependency, and here the your POM depend on some motion direct and transitive dependency here. Here you can see the parent POM and super POM. Any project may be a child of a parent. Project silently inherit from super POM, which is a global Maven standard parent POM. Children may also be aggregated by a parent without them knowing, or for convenient built for larger projects. Here you can see any POM inherits Maven super POM, and parent 1 POM inherit Maven super POM, and parent 1 POM aggregate submodule 1 POM and submodule 2 POM here. Now here you can see the parent POM and super POM. The children may children may inherit dependencies, properties and settings and plugins, etc. from parents, making it possible to share common ground. Both apertures may combine, may be combined. The children may import as many BOMs as they want, but can have only a single parent to inherit from at a time. Here you can see a parent POM inherits Maven super POM. Here the parent POM aggregates submodule 1 POM and submodule 2 POM here, and submodule 1 POM inherits parent, and submodule 2 POM inherits parent POM, and here the dependency here inherit is parent submodule 1 POM is connected to dependency via inherit depends on, submodule 2 POM is connected to dependency via inherit depends on, and parent POM is connected to dependency via depends on. Here you can see transitive dependencies. Maven is compatible. Maven is comfortable for developers. It handles recursive resolution, downloading and adding and dependency of dependencies. However, as lifecycle of a box coordinate, you might find yourself in version conflict hell sooner or later without knowing, but experiencing unintended side effect. When you look at the topmost in this case here the version 2.0 will be included. If you know something about semantic versioning, the red alert should ring in your mind right now. How do we know that B is compatible with Z version 2.0 when depending on Z version 1.0? Another scenario getting us in trouble, a direct use of transitive dependencies. Imagine the following we rely on Z in our code, but do not include a direct dependency for it. Within the POM. Now assume B is updated and removed its dependency on Z. You definitely don't want to head down that road. Follow the rules to be safe. 1. Do not use transitive dependencies implicitly. Add the direct dependency for transitive depths you reuse in your code. To the even on every build, check that no implicit usage was added by accident. 3. Explicitly declare versions of transitive dependencies in use of multiple direct dependencies. On every build, check that there are no converge problems hiding in the shadows. 5. Do special test on every build to verify these explicit combinations work. You can manage versions of transitive dependencies in 4 ways. One is explicitly declare transitive dependency in dependency management within the version tag. That's a good and safe practice. And 2 is for more complex transitive dependency, use bill of materials BOM within dependency management. Many bigger projects provide them, making the POM much less bloated compared to adding every bit yourself. That's a safe and good practice. And 3, using optional and exclusion tags on direct dependency that request the transitive dependency. Last resort, you really should avoid this, not explained or used here. It's better to avoid or don't. And 4, make transitive only dependency not use in code and direct use one and add version tag. Typically bad idea, don't do that. And this is another better avoid or don't. And here you can see your code is connected to direct dependency B, and here set version 2.0 and direct dependency B is connected to shed version 1.0 here. Here you can see a short comparison with Ant in Maven dependency management. What is the difference between Maven dependency management and Ant dependency management? First of all, the Ant only manages project build phases, delegating dependency management to Apache Ivy. This works together. Therefore, the two tools handles a different task in details. First, the Ant runs built from build.xml file. Ivy downloads dependencies written in a list inside iv.xml file into local repository. On the other hand, the Maven manages both aspect build phases and dependencies starting from a single file called pom.xml. The note this actually the Maven has built-in phases that can be managed by developer from pom.xml. On the other hand, working with Ant phases must be created from build.xml. Here you can see here the Ant project root directory. Here the build.xml is connected to contain the description of build phases, and here iv.xml is connected to contains dependencies list. Here the Maven project root directory, and here the pom.xml is connected to contains description of build phases and the dependencies list. Here you can see the structure of the pom.xml file. The POM file is an XML file that contains all project information and instruction for Maven program MVN to build the project. Here's a quick description of POM file with the main section and how to fill them. Again, Here you can see the parent POM reference. This is optional, and here you can see then we are coming to artifact definition and description. Here you can see the artifact ID, the unique ID name, no uppercase character and space, group ID, unique group ID, institution name, no uppercase character and space, version number, format is major.minor, patch add dash snapshot suffix for in progress version. Here you can see the packaging, name, description, URL, organization, licenses, developers, etc. Here you can see a build definition. The instruction used to build the project, Java compiler, Java compiler version, inclusions, exclusion, or inclusions or exclusions patterns, specific specific jar generation. Lot of things can be done here. Here the list of dependencies, all dependencies required by the projects. Here the external repositories, links, external repository links and deployment information. Give the give target link for third-party artifacts and target link for uploading the artifact on the Maven server. Here you can see the version requirements have the following syntax in dependency version requirement specification. Dependencies version element define versions requirements which are used to compute dependency versions. Soft requirements can be replaced by different versions of the same artifact found elsewhere in the dependency graph. Hard requirements mandate the particular version or versions and over soft requirements. If there are no versions of the dependency that satisfy all hard requirements for that artifact, the build fails. The version requirements have the following syntax. Here this one, the soft requirement for 1.0, and use 1.0 if no other version appears earlier in the dependency tree. Here the hard requirement for 1.0, use 1.0 and only 1.0. Here the hard requirement for any version less than 1 point less than or equal 1.0. Here the hard requirement for any version between 1.2 and 1.3 inclusive. Here the 1.0 less than grade less than or equal x less than or equal and less than or equal 2.0. The hard requirement for any version between 1.0 and inclusive and 2.0 exclusive. Hard requirement for any version greater than or equal to 1.5. Hard requirement for any version less than or equal to 1.0 then or greater than or equal to 1.2 but not 1.1. Multiple requirements have separate commas. Here the hard requirement for any version except 1.1. For example, because 1.1 has the critical vulnerability, Maven picks the highest version of each project and Maven picks the highest version of each project that satisfy all the hard requirement of the dependencies on that project. If no version satisfies all the hard requirements, the build fails. Now as an example, we can consider the minimum requirement for a POM are following. The minimum requirement for a POM are following here: project root model version should be at least should be set to 4.0.0 this version, and group ID, the ID of the project's group, artifact ID, the ID of the artifact project, the ID of the artifact project, version, the version of the artifact under the specified group. The POM requires that it's a group ID, artifact ID, and version be configured. These are three values from project's fully qualified artifact name. This is in the form of group ID colon artifact ID colon version. As an example, we can consider here com.mycompany.app colon my dash app colon 1. Also, if configuration details are not specified, Maven will use their defaults. One of these default values is the package type. Every Maven package, every Maven project has a package name, package type. If it is not specified in the POM, then the default value jar would be used. Furthermore, you can see that in the minimal POM here, the repositories are not specified. If you built your project using the minimal POM here, it would inherit the repositories configuration in the super POM. Therefore, when Maven uses the dependencies in this minimal POM, it would know that these dependencies will be downloaded from https repo.maven.apache.org./maven2, which has specified in the super POM. As an example 2, we can consider this one, the plugins. Here, beyond the standard coordinate of group ID colon artifact ID colon version, there are elements which configure the plugin or these builds interact with extensions, true or false, whether or not to load extensions of this plugins. It is by default false. Extensions are inherited, true or false, whether or not this plugin configuration should apply POMs which inherit from this one. Default is true. Configuration, this is specific to individual plugin. Without going too in depth into the mechanics of how plugin works, suffix it to say that whatever properties that the plugin mojo may expect, these are getters and setters in the Java mojo bin, for example, can be specified here. In this example, we are setting the classifier property to test Maven dash jar.plugin in Mojo. It may be good to note that all configuration elements wherever they are within POM are intended to pass values to another underlying system such as a plugin. In other words, values within configurations element are never explicitly required by the POM schema, but the plugin goal has every right to require configuration values. Dependencies are seen a lot within POM and are an element under all plugin element blocks. Dependencies have the same structure and function as under the base build. The major difference in this case is that instead of applying as dependencies of the project, they now apply as dependencies of the plugin that they are under. The power of this is to alter the dependency list of a plugin, perhaps removing an unused runtime dependency via exclusions or by altering the version of a required dependency. Executions. It is important to keep in mind that the plugin may have multiple goals. Each goal may have a separate configuration, possibly even building a plugin goal to a different pace together. Executions configure the execution of a plugin goals. For example, suppose you wanted to bind the /run goal to the verify pace. We want the task to echo the build directory as well as avoid passing on this configuration to its configuration, assuming it is a parent by setting inherited or false. Now we are considering the field static final POM here in interface type in package org.apache.maven .api. Now we are considering package org.apache.maven.api.model, Maven immutable POM, project object model classes generated from Maven.mdo model. The root class is model. Now we are considering interface super POM provider in package org.apache.maven.api.services, provides the super POM that all models implicitly inherit from. Now we are considering Maven. This is reference for the Maven project descriptor used in Maven. The project in Maven, this element is the root of the descriptor. It has elements like group ID, artifact ID, version, relative path. Regarding API, the interface project in package org.apache.maven.api interface representing a Maven project. Projects can be built using project builder service. Parent, this element contains the parent element contains information required to locate the parent project from which this project will inherit from. Not the children of this element are not interpolated and must be given as literal values. With regarding API, the class parent in package org.apache.maven.api model, the parent element contains information required to locate the parent object from which the project will inherit from. Not the children of this element are not interpolated and must be given as literal values. Organization specifies the organization that produces this project. With the API class organization, in package apache.maven.api.model. Specify the organization that produces this project. License, describe the licenses for this project. This is used to generate the license page of the project's website, as well as being taken into consideration in other reporting and validation. The licenses listed for the project are that of the project itself and not of dependencies. The class license in package apache.maven.api.model. Describe the licenses for this project. This is used to generate the license page of the project's website and as well as the being taken into consideration in other reporting and validation. The licenses listed for the project are that of the project itself and not of dependencies. Developer, information about the one of the committers on this project. The class developer regarding API, the class developer in package apache.maven.api.model. Information about one of the committers on this project. Contributor, description of a person who has contributed to the project but who does not have commit privileges. Usually these contributors come in the form of patches submitted. Class regarding API, class contributor in package apache.maven.api.model. Description of a person who has contributed to the project who does not have commit privileges. Usually these contributions come in the form of patches submitted. Mailing list, this element describes all of the mailing list associated with the project. The auto-generated site references this information. The class mailing list in package apache.maven.api.model. This element describes all of the mailing list associated with the project. Auto-generated site references this information. Prerequest, describe the prerequest a project can have. Class prerequest in package apache.maven.api.model. Describe the prerequest a project can have. SCM, the SCM element contains information required to the SCM, source control management of a project. Regarding API, the class SCM in package apache.maven.api.model. The SCM element contains information required to the SCM, source control management of the project. Issue management, information about the issue tracking or bug tracking system used to manage this project. Class issue management in package apache.maven.api.model. Information about the issue tracking or bug tracking system used to manage this project. CI management, the CI management element contains information required to the continuous integration system of the project. The class CI management in package apache.maven.api.model. The CI management element contains information required to the continuous integration system of the project. The notifier configures one method for notifying users or developers when a build breaks. Class notifier in package apache.maven.api.model. Configured one method for notifying users or developers when a build breaks. Distribution management. This element describes all that pertains to distribution for a project. It primarily used for deployment of artifact and the site produced by the build. Class distribution management in package api.model. This element describes all that pertains to distribution for a project. It is primarily used for deployment of artifact and the site produced by the build. Releases. The download policy. With regarding API, the method at not null public deploy repository dot builder release releases repository policy releases in class deployment repository dot builder in package apache.maven.api.model. Snapshots is a download policy, and in regarding API at not the method at not null at non null public deployment repository dot builder snapshots repository policy snapshots in class deployment repository dot builder in package apache.maven.api.model. Relocation, describe where an artifact has moved to. If any of the values are omitted, it is assumed to be the same as it was before. Class relocation in packaged API.model. Describe where an artifact has moved to. If any of the values are omitted, it is assumed to be the same as it was before. Dependency management. Section for management of default dependency information for use in a group of POMs. Regarding API, the class dependency management in package API.model. Section for management of default dependency information for use in a group of POMs. Dependency, the dependency element contains information about dependency of the project. The class dependency in package org.apache.maven.api.model. The dependency element contains information about the dependency of the project. Exclusion, the code, the exclusion element contains information required to exclude an artifact to the project. The class exclusion in package org.apache.maven.api.model. The exclusion element contains information required to exclude an artifact to the project. Built. The built element contains information required to build the project. Default values are defined in a superpom. Regarding API, the class built in package org.apache.maven.api.model. The built element contains the information required to build the project. Default values are defined in the superpom. Extension. Extension describes built extension to utilize. With regarding API, the class extension in package org.apache.maven.api.model describe built extension to utilize. Resource. This element describe all the class path info resources associated with the project or unit test. With regarding API, the class resource in package org.apache.maven.api.model. This element describe all of the class path resources associated with the project or unit test resource. This element describe all of the class path resources associated with the project or unit test. With regarding API, the method at non-null public build.build test resources, collection resource, test resources in class build.build in package org.apache.maven.api.model. Plugin management. Section for management of default plugin information for use in a group of POMs. With regarding API, the class plugin management in packaged org.apache.maven.api.model. Section for management of default plugin information for use in a group of POMs. Plugin, the plugin element contains information required for a plugin. The class plugin in package org.apache.maven.api.model. The plugin element contains information required for a plugin. Execution, the execution element. The execution element contains information required for execution of a plugin. With related to API, the class plugin execution. In the package org.apache.maven.api.model. The execution element contains information required for execution of a plugin. Reporting. Section for management of reports and their configuration. With regarding API, the class reporting in package org.apache.maven.api.model. Section for management of report and their configuration. Plugin. The plugin element in contains information required for a report plugin. Regarding API, the class plugin in package org.apache.maven.api.model. The plugin element contains information required for a plugin. Report set represent a set of reports and configuration to be used to generate them. Regarding API, the class report set in package org.apache.maven.api.model represent a set of reports and configuration to be used to generate them. Profile modification to the build process, which is activated based on the environment parameters, so command line arguments. Regarding API, the class profile in package org.apache.maven.api.model, the modification to the build process, which is activated based on the environment parameters, so command line arguments. Activation. The conditions within a built runtime environment which will trigger the automatic inclusion of a build profile. Multiple conditions can be defined which must be satisfied to activate the profile. Regarding class API, the class activation in package API.model, the conditions within the built runtime environment which will trigger the automatic inclusion of build profile. Multiple conditions can be defined and which must be all satisfied to activate the profile. OS, this is an activator which will detect an operating system's attribute in order to activate its profile. Class with regarding API, the class activation OS in package apache.maven.api.model. This is an activator which will detect an operating system's attribute in order to activate its profile. Property. This is the properties specification used to activate the profile. If the value is an empty, then the extension of the named property will activate the profile. Otherwise, it does case sensitive match against the property value as well. With regarding API, the class activation property in package apache.maven.api.model. This is the property specification used to activate the profile. The value field is empty. Then the extension of the name property will activate the profile. Otherwise, it does not. Thus, the case sensitive match against the property value as well. File. This is the file specification used to activate the profile. The file value is the location. The missing value is the location of the of a file that needs to exist, and if doesn't, the profile will be activated. On the other hand, the exist will test for an existence of the file, and if it is there, the profile will be activated. With regarding API, the class activation file in package apache.maven.api.model. This is the file specification used to activate the profile. The missing value is the location of the file that need to exist, and if it doesn't, the profile will be activated. On the other hand, the exist will test for existence of the file, and if it is there, the profile will be activated. Build. The build configuration in a profile. The class built in package apache.maven.api.model. The build element contains the information required to build the project. Default values are defined in the super POM. Now we are considering what is POM in introduction to POM. The example for this is the build directory with the file regarding the file structure, which is the target, the source directory, which is the source main Java, the test source directory, which is source test Java, and so on. And a project object model, or POM, is a fundamental unit of work in Maven. It is an XML file that contains information about the project and configuration details used by Maven to build the project. It contains different default values for most projects. Example for this is the build directory, which is the target, the source directory, which is source main Java, and the test directory, which is source test Java, then and so on. When executing a task or goal, Maven looks for a POM in the current directory. It reads the POM, gets the needed configuration information, then executes the goal. Some of the configuration that can be specified in the POM are the project dependencies, the plugins or goals can be executed, the build profile, and so on. Other information such as project version, description, developers, mailing list, and such can be specified. Now we are considering a super POM. You can see the super POM for Maven 3.6.3 in Maven core reference documentation. This is a segment of it. The super POM is Maven's default POM. All POMs extend the super POMs unless explicitly set, meaning the configuration specified in the super POM is inherited by the POMs you created for your projects. Now we are considering minimal POM. Here is an example. The minimum requirement for a POM are following here. Project root, module version should be set to here 4.0.0 here. Group ID, the ID of the project's group. Artifact ID, the ID of the artifact's project. Version of the artifact under the specified group. Here's an example. POM requires its group ID, artifact ID, and version be configured. These three values from the project's fully qualified artifact name. This is in the form of group ID, colon artifact ID, colon version. As for the example here, its fully qualified artifact name is com.company.app colon my-app colon 1. Also, as mentioned before, if the configuration details are not specified, the Maven will use their defaults. One of those defaults values is the packaging type. Every Maven project has a packaging type. If it is not specified in the POM, then the default value jar would be used. Furthermore, you can see the minimal POM, the repositories were not specified. If you build your project using minimal POM, it would inherit the repositories configuration in the super POM. Therefore, the Maven sees the dependencies in the minimal POM. It would know that these dependencies will be downloaded from https://report.maven.apache.org/maven2, which was specified in the super POM. We are considering example in project inheritance. The example com.mycompany.app colon my dash module colon 1 POM. Here as an example, let us reuse the artifact. This one, the com.company.app my dash app 1 colon 1, and let us introduce another artifact com.mycompany.app colon my dash module colon 1. Here this one, and let us specify their directory structure as the following. They note the my dash module /pom.xml is the POM of the com.company.app colon my dash module colon 1, while the pom.xml is the POM of the com.company.app colon my dash app colon 1. The solution is here. Now if we were to turn the com.mycompany this one .app colon my dash app to 1 into parent artifact of the com.mycompany my dash module colon 1. So we'll have to modify the com.mycompany.app my module colon 1's POM in the following configuration. This is com.mycompany.app colon my dash module colon 1's POM. Notice that we now have an added section, the parent section. This section allows us to specify which artifact is the parent of our POM, and we do so by specifying the fully qualified artifact name of the parent POM. With this setup, our module can now inherit some of the properties of our parent POM. Alternatively, you can now if you want the group ID or version ID, group ID or the version of your modules to be the same as your parent, you can remove the group ID or version identity of your module in its POM. This allows here this one. This allows This allows the module to inherit group ID or version of its parent's POM. Now we are considering project example in project aggregation. Here the with related to the previous scenario with the previous original artifact POMs and directory structure, here the com.mycompany.app colon my dash app colon 1 one's POM here, and here the com.mycompany.app my dash module my module colon my dash module colon 1, and here the directory structure. The solution is here. Then if we want to aggregate my module into my app, we would only have to modify my app. In the revise com.mycompany.app my dash app colon 1, the packaging section and the module section were added. For packaging, its value was set to POM, and for module section we have the element module, my dash module. The value of module is the relative path from the com.mycompany.app colon my dash app colon 1 to com.mycompany.app colon my module colon 1 one's POM. By practice, we use the module's artifact ID as the module's directory name. Now whenever a Maven command processes com.mycompany.app colon my dash app colon 1, that same Maven command would be run against the mycompany.app colon my dash module colon 1 as well. Furthermore, some commands goal specifically handle project aggregation differently. Now we are considering project inheritance versus project aggregation. Here you can see com.mycompany.app colon my dash app colon 1's POM. Given the here the com.mycompany.app colon my app colon one spom. Here this one, and here the com.mycampaign.app colon my dash module colon one spom. This is the and this directory structure. This is my module here. The solution is the to do the both project inheritance and aggregation. You only have to apply all three rules. The three rules are: specify every child POMs in who their parents POMs is, and change the parent POMs packaging to value POM, and specify parent POMs directories in its modules. Here the here the com.mycompany.app colon my dash app colon one's POM here. And here the com.mycompany.app colon dash dash my module, the my dash module and colon one's POM. Now we are considering special variables in available variables in project interpolation and variables. Here the the format of the Maven build timestamp can be customized by declaring the property maven.build.timestamp.format as shown in this example. The Maven build.timestamp maven.build.timestamp the timestamp that denotes the start of the build UTC since Maven 2.1.-M1. The format pattern has to comply with the rules given in the API documentation for simple date format. If the property is not present, the format default to the value already given in the example. Here you can see a quick overview in POM reference. This is a listing of the element directly under POM's project element. Notice that module version contains 4.0.0. That is the currently only supported POM version and is always required. The basics, the build settings, more project information, environment settings, now Now we are considering basics. This is unlike a build.xml file where the tasks are almost always dependent on the lines executed before it. The POM contains all necessary information about the project, as well as configuration of plugins to be used during the build process. This is a declarative manifestation of the who, what, and where while build lifecycle of when and how. That is not to say that POM cannot affect the flow of the lifecycle. It can, for example, by configuring Maven ant run plugin. You can embed Apache ant task inside the POM. It is ultimately a declaration, however, whereas a build.xml tells the ant precisely what to do when it is run procedural. The POM states its configuration declarative. If some external force causes the lifecycle to skip and the ant plugin execution, it does not stop plugins that are executed from doing their magic. This is unlike a build.xml file where the tasks are almost always dependent on the lines executed before it. Now we are considering Maven coordinates in basics. This marks a specific place in the repository, acting like a coordinate system for Maven projects. The project defines before bare minimum that allows the group ID dot artifact ID group ID colon artifact ID colon version are all required fields, although group ID and version do not need to be specifically defined if they are inherited from a parent. The three fields act much like an address and timestamp in one. This makes a specific place in a repository, acting like a coordinate system for Maven projects. Group ID. This is generally unique amongst an organization or a project. For example, all core Maven artifacts do well should live under the group ID or Apache.maven. Group IDs do not necessarily use the dot notation. For example, JUnit project. Note that the dot notation notated group ID does not have to correspond to the package structure that the projects contain. It is, however, a good practice to follow. When stored within the repository, the group ID acts much like the Java packaging structure does in operating system. The dots are replaced by OS-specific directory structure such as / in Unix, which becomes a relative directory structure from the base repository. In the example given, the org.code host.mojo.group Mojo group lives in the directory $m2_repo/org/code/code/mojo. Artifact ID. The artifact ID is the generally name that the project is known by, although the group ID is the important. People within the group will rarely mention the group ID in the discussion. They are often all be the same ID, such as Mojo host project group ID, org.code host.mojo. It along with the group ID creates a key that separates this project from every other project in the world. At least it should. Among with the group ID, the artifact ID fully define the artifact's living quarters within the repository. In the case of above project, the my project lives in $m2_repo/org/code/host/mojo/my-project. Version. This is the last piece of the naming puzzle. Group ID artifact ID denotes a single project, but they cannot delineate which incarnation of the projects we are talking about. Do we want the JUnit of 2018 version 4.12 or the 2007 version 3.8.2? In short, code changes. Those changes should be versioned, and this element keep those versions in line. This is also used within an artifacts repository to separate versions from each other. My dash project version 1.5 files live in the directory structure $m2 underscore repo /org /quotas /mojo /my dash project 1.0. The three elements given here point to a specific version of a project. Letting Maven know who we are dealing with and when its software lifecycle we want to use, we want them. Now we are considering packaging. We could make it into a var by declaring a different packaging. In API, the method at not null public model dot builder packaging string packaging in class model dot builder in package or apache dot maven dot api dot model. Now we have addressed the structure of group ID artifact ID version. There is one more standard label to give us really complete what that is the project's packaging. In our case, the example pom for org.codehost.mojo my dash project 1.0 defined above will be the package dash previous one as jar. We could make it into a var by declaring a different packaging. When no packaging is declared, Maven assumes the packaging is the default jar. The valid types are plexus role hints. Read more on plexus for explanation of roles and role hints of the component role. org.apache.maven.lifecycle.mapping.lifecycle mappings. The current core packaging values are pom, jar, maven dash plugin, egb, var, er, rar. These define the default list of goals which execute on each the corresponding build lifecycle stage for a particular package structure. Now we are considering dependencies in POM relationships. As an added bonus, the Maven brings on the dependencies, those dependencies, transitive dependencies, allowing for your list to focus solely on the dependencies your project requires. With the API, we can consider at not null public model.builder dependencies collection dependencies in class model.builder in package org.apache.maven.api.model. The cornerstone of the POM is its dependency list. Most project depends on others to build and run correctly. If Maven does for you is the manage this list, you have gained a lot. Maven downloads and links the dependencies on compilation, as well as other goals that require them. As an added bonus, Maven plugins in the dependencies of those transitive dependencies, allowing your list to focus solely on the dependencies your project requires. Group ID and artifact ID and version. You will see this element often. This trinity is used to compute the Maven coordinates of a specific project in time, demarcating it as a dependency of this project. Purpose of this computation is to select the version that matches all the dependency declaration due to transitive dependencies. There can be multiple dependency declaration for the same artifact. The value should be group ID and artifact ID directly corresponding to the group coordinates of the dependency, and version, the dependency version requirement specification that is used to compute the dependency's effective version. Since the dependency is described by Maven coordinates, you may be thinking this means that my project can only depend upon the Maven artifact. Answer is of course, but that's a good thing. This focuses you to depend solely on dependencies that Maven can manage. There are times, unfortunately, when a project cannot be downloaded from the central Maven repository. For example, the project may depend on a jar that has a closed source license which prevent it from being a central repository. There are three methods for dealing with this scenario. One, install the dependency locally using install plugin. The method is simplest and recommended method. To create your own repository and deploy it there, this is a favorite method for companies with the intranet and need to be able to keep everyone sync. There is a Maven goal called deploy-file, which is similar to the install-file goal. Read the plugins goal page for more information. 3, set the dependency scope to system and define the system path. That's not recommended, however, but leads to lead us to explaining the following element. Classifier distinguishes the artifact that were built using from the POM but differ in the content. It is the same optional and arbitrary string that it percent is append to the artifact name just after the version number. As a motivation for this element, consider for example a project that offers an artifact targeting Java 11, but at the same time it's also an artifact that still supports Java 1.8. The first artifact could be equipped with the Java with the classifier JDK 11 and the second with the JDK 8, such that client can choose which one to use. Another common use case for classifiers is to attach secondary artifact to the project's main artifact. If you browse the Maven Center repository, you will notice that the classifier sources and Java docs are used to deploy the project source code and API docs along with the package class files. Type correspond to the chosen dependency type. Default to jar. When it usually represents the extension on the file name of the dependency, that is not always the case. A type can be mapped to a different extension and a classifier. The type often corresponds to the packaging used, though this is also not always the case. Some examples are jar, ejb-client, and test-jar. New types can be defined by plugins that set extensions to true. So this is not a complete list. Scope, this element refers to the class path of the task at hand, compiling and runtime testing, etc., as well as how to limit the transitivity of dependency. There are 5 scopes available. Compile, this is the default scope used if none is specified. Compile dependencies are available in class paths. Furthermore, those dependencies are propagated to dependent project. Provided, this is much like compile but indicates you expect JDK or a container to provide it at runtime. It is only available on compilation and test class path, and it's not transitive. Runtime, the scope indicates that the dependency is not required for compilation but is for the execution. It is in the runtime and test class path but not in compiled class path. Test, this scope indicates that the dependency is not required in the normal use of application, but it's only available for the test, compilation and execution phases. It is not transitive. And system, this scope is similar to provided, except that you have to provide the jar which contains it explicitly. Artifact is always available and is not looked up in the repository. System path, use only for dependency scope is system. Otherwise, the build will fail if this element is set. The path must be absolute, and so it is recommended to use the property to specify the machine specific path, such as $, open curly brace java.home, closing curly brace /lib. Since it is assumed that the system scope dependencies are installed in a priori, Maven does not check the repositories for the project, but instead check to ensure that the files exist. If not, Maven fails the build and suggests that you download it and install it manually. Optional marks the dependency optional when this project itself is a dependency. For example, imagine a project A that depends upon project B to compile a portion of code that may not be used at runtime. Then we may have no need for a project B for all project. If so, the project X adds project A as its own dependency. Then Maven does not need to install project B and at all. The symbolically, if / greater than sign represent required dependency and dash greater than sign represent optional, although A equal and greater than A lead to B may be the case when building X to A to B would be the case building X. In the shortest terms, optional lets other projects know that you use this project and do not require this dependency in order to work correctly. Now we are considering properties. Their values are accessible anywhere in the POM by the using notation here, the $x, where the x is the property, or they can be used by plugins as default values. For example, in API, the public the method at non-null public model dot builder properties map string properties. The properties are the last required place to understand POM basics. Maven properties are value placeholders like properties in AND. Their values are accessible anywhere within POM by using a notation $sign and here the open curly brace x close curly brace where x is a property, or can be used by plugins as default values. For example, here they come from 5 different types. One is the env.x. Prefixing a variable with env will return the shell environment. For example, $env path contains the path environment variable. The project .x or dot notated path in the POM will contain the corresponding elements value. For example, project version 1.0 is accessible via project.version. Settings.x a dot notated the path in the settings.xml will contain the corresponding elements value. Java system properties, all properties accessed via java.land.system.get properties are available as POM properties such as open curly brace java.home close curly brace x set with the within properties element in the POM. Following project properties are reserved for Maven will become elements in future POM definition. Don't start your POM on properties with project. Here we are considering base built element set in built settings. Base built is exactly as it sounds, the base set of element between two built element of the POM. Here the default goal the default goal of OP is to execute if none is given. If a goal is given, it should be defined as it is in the command line, such as jar jar. The same goes for the if a pace is defined, such as install. Directory, this is the directory where the build will dump its file, or in Maven parlance, the build's target. It aptly default to $ open curly base close curly base target directory. Final name, this is the name of the bundle project when it is finally built. Since the file extension, for example, my-project 1.0 jar. It default to $artifact ID and $version. The term file name term final name is a kind of misnomer. However, as plugins that build the bundled project have every right to ignore or modify its name, but they usually do not. For example, if the Maven jar plugin is configured to give you a jar, a class classifier of test, then the actual jar defined above will be built as my-project 1.0 test jar. Filter defines *properties files that contain list of properties that apply to resources which accept their settings. In other words, the name equal value pairs defined within the filter files replace $open curly base name close curly base strings within resource on build. The examples here defines the filter.properties file under the filters directory. Maven's default filter directory is $based directory /source then /source /main /filters. Now we are considering licenses in more project information. Licenses are legal documents defining how and when the project or parts of a project may be used. Regarding API, we can consider @not-null, the method @not-null, public model.builder licenses, collection licenses in class model.builder, in package of API.model. Licenses are legal. A project should list licenses that apply directly to this project and not list licenses that apply to the project's dependencies. Name, URL, and comments are self-explanatory and have been encountered before it in other context. Using an SPDX identifier as the license name is recommended. The fourth license element is a distribution. This describes how the project may be legally distributed. The two standard methods are repo. They may be downloaded from the Maven repository, or manual. They may be manually installed. Now we are considering issue management in environment settings. Although there is nothing stopping the plugin from using this information for something, it's primarily used for generating project documentation. This defines the in the class with regarding API, the class issue management in package apache.maven.api.model, information about the issue tracking or bug tracking system used to manage this project. This defines then the defect tracking system, Bugzilla, test track, clear, quest, etc. used. Although there is nothing stopping the plugin from using this information for something, it is primarily used for generating project documentation. Now we are considering the final. The Maven POM is big, however its size is also a testament to its versatility. The ability to abstract all of the aspect of a project into a single artifact is powerful, to say the least. Gone are the days of dozens of disparate build script and scattered documentation concerning each individual project. Along with Maven's other stars that make up the Maven galaxy, a well-defined build lifecycle, easy to write and maintain plugin centralized repository, system-wide and other user-based configuration, as well as the increased number of tools to make developers' jobs easier to maintain complex projects. The POM is a large but bright center. Now we are considering profiles in external files, in which areas of a POM can be customized by each type of a profile and why, and in introduction to build profile. Profiles specified in external files, that is in settings.xml or profiles.xml, are not portable in strictest sense. The class with regarding API, the class settings in package maven.api.settings, the root element of the configuration file. Profiles in external files, profiles specified in external files, that is in settings. So profiles.xml are not portable in a strict sense. Anything that seems to stand a high chance of changing the result of a build is restricted to the inline profile on the POM. Things like repository list could simply be a proprietary repository of approved artifact and won't change the outcome of the build. Therefore, you will only be able to modify the repositories and plugin repositories sections plus the extra properties section. The properties section allows you to specify freeform key value pairs, which will be included in the interpolation process for the POM. This allows you to specify a plugin configuration in the form of $open curly brace profile.path close curly brace. Now we are considering profiles in POMs. The profile specified in POMs can modify the following POM element. On the other hand, if your profiles can be reasonably specified inside the POM, you have many more options. Trade-offs, of course, that is that you only modify that project and its submodules. Since these profiles are specified inline there, and therefore they have a better chance of perceiving portability, it is reasonable to say you can add more information to them without risk of having information being unavailable to other users. Profiles specified in the POM can modify the following POM elements: repositories, plugin repositories, dependencies, plugins, properties not actually available in the main POM but used behind the scenes, modules, reports, reporting, dependency management, distributed management, a subset of built element which consists of default goal, resources, test resources, directory, final name, filters, plugin management, and plugins. POM element outside profiles. We don't allow modification of POM elements outside of POM profiles because this runtime modification will not be distributed when POM is deployed to the repository system, making the versions built of that project completely unique from others. While you can do this to some extent with the options given for external profiles, the danger is limited. Another reason is that the POM info is sometimes being reused from the parent POM. External files such as settings.xml and profiles.xml also do not support element outside the POM profiles. Let us take a scenario for elaboration. When the effective POM is deployed to an remote repository, any person can pick up its info out of the repository and use it to build Maven project directly. Now imagine that if we can set profiles in dependencies which are very important to a build and any other information outside the POM profiles in the settings.xml, the most probably we cannot expect someone else to use the POM from the repository and be able to build it. And we have to also think about how to share the settings.xml with others. Note that too many files to configure are very confusing and very hard to maintain. Bottom line is that since this is built data, it should be in the POM. Now we are considering bill of materials bombs on POMs. Imports are most effective when used for defining a library in POMs, and the other projects have wished to use the library should import this POM into dependency management section in their POM. Imports are most effective. So in the API, we can consider class dependency management in package Apache.maven.api model section for management detailed dependency information. Imports are most effective when used defining a library of related artifacts that are generally part of multi-project build. It is fairly common for one project to use one or more artifacts from these libraries. However, it has sometimes been difficult to keep versions of the project using artifact in sync with the version distribution library. Pattern below here allows how build of materials BOM can be created for use by other projects. The root project is the POM. It defines versions of all artifacts that will be created in the library, and other projects that wish to use the library should import this POM into dependency management section in their POM. The parent subproject has the POM as its parent. It is a normal multi-project POM. And the next actual project's POMs. Sorry. The project as follows shows the library that can be used in another project without having specifically dependent on versions. Finally, when we create projects that import dependencies, beware of the following. Do not attempt to import POMs that define a submodule of the current POM. Attempt to do this will result in failing, since it won't be able to locate the POM. Never declare POMs importing a POM as parents or grandparents, etc. of the target POM. There is no way to resolve the circuitry, and exception will be thrown. When referring to artifact, those POMs have transitive dependencies. The project needs to specify versions those artifacts are as managed dependencies. Not doing so result a build failure, since artifact may not have been version specified. This should be considered the best practice in any case, at least keep versions of artifacts from changing from one build to next. sorry, this one DOM, and here artifact. Here the this one, and the and here the artifact ID is project 1 here. Now we are considering guide to create create the prototype files and the prototype pom.xml in guide to create archetypes. Next, the component of the archetype to be created is create an example for a prototype pom.xml is here. Then the next the archetype to be created is the prototype pom.xml. Any pom.xml will do. Just don't forget to the set artifact ID and group ID variables $sign open curly brace artifact ID close curly brace $$ open curly brace group ID close curly brace. Both variables will be initialized from the command line when calling archetype generate. An example for a prototype pom.xml is here. Now we are considering injecting pom property settings.xml in plugin configuration and injecting pom properties via settings.xml in example. We have plugin parameter that should contain a user specific value. This parameter have a common format creative directory structure, but depend on knowing the directory of the install application or something. Here the project configuration is here. Here you can see the settings .xml. When Maven loads the project POM, it will pick up the activated profiles from the active profiles section of the settings XML, settings.xml file and inject properties declared within the profile. When POM is interpolated, the application -home property will already been injected, so it will allow the plugin parameter value to be resolved. Now we are considering project the project descriptor POM POM requirements in introduction in Mojo API, the POM must declare a packaging element which describe this project as a Maven plugin project. Here you can see a packaging Maven dash plugin. With regarding API, we can consider the method at non-null public model.builder packaging string packaging in class model.builder in package Apache.maven.api.model. Now we are considering POM code conventions in XML in Maven code style and code conventions. The following is the recommended ordering of Maven POM files. The team has voted during the end of June 2008 to follow a specific POM convention to order POM element. The sequence of this vote is that the Maven project descriptor is no more considered as the reference for ordering. The following is the recommended ordering of Maven POM files. The comments: the project element is always on one line. The blocks are voluntarily separated by a new line to improve readingness. 3. The dependencies on in the dependencies in dependencies and dependency management tags have no specific ordering. Developers are free to choose the ordering, but grouping dependencies by topic like grouped ID, that is org.apache.maven, is a good practice. This should be in one line, obviously. Error example, we can consider this one occurred in the environment with pipeline of a Java project and Git repository. Not found Maven POM file. Error unhandled. Not found Maven POM POM file /home/vsds/work/1/s/pom.xml. Finishing Maven pom.xml. Now we are focusing on Maven. Here you can see Apache Maven internal design architecture. This is Maven 4.x. Apache Maven is a project development, management and comprehension tool based on the concept of a project object model. Builds, dependency management, documentation creation, site publication and distribution publication are all controlled from the pom.xml declarative file. Apache Maven can be extended by plugins to utilize number of other development tools for reporting and build process. Here is a diagram that shows the internal design architecture of Apache Maven. Apache Maven modules are labeled in this colored boxes, and third-party modules are labeled in uncolored boxes here, and this one also. Here you can see a distribution. Distribution is connected to SLF4J-provider SLA, and it is connected to SLF4J-wrapper, and also distribution is connected to embedder, and you can see here BOM, and embedder is connected to SL4J-wrapper and also connected to Compact, and Compact is connected to core, and core is connected to plugin -mp API, and core is connected to toolchain builder, and settings builder and resolver provider. Toolchain builder is connected to toolchain model, and settings provider is connected to settings builder support, and and model builder is connected to builder support, and also connected to model transform and model and artifact. And here resolver provider is connected to repository metadata, and you can see here embedder is connected to commons CLI, and SL4J-wrapper is connected to SL4J API, and core is connected to shared utils, and shared utils is connected to Jansi, and plugin API is connected to Sisu, and inside it you can see a plugin API is connected to Perplex, and in Sisu you can see Plexus and Inject. Plexus is connected to Inject is connected to Juice, and Plexus is connected to class worlds, and inside the Plexus you can see class worlds, interpolation, sec dispatcher, Cyper, and utils, toolchain builder, settings builder, and model builder are connected to interpolation. Settings builder is connected to sec dispatcher, and resolver provider is connected to IMPL. Inside the resolver you can see IMPL, SPI, API, and util. IMPL is connected to SPI and util. SPI is connected to API, and util is connected to API. Here you can see a standard Maven directory layout. Having a common directory layout allows users familiar with one Maven project to immediately feel at home in another Maven project. The advantages are analogous to adopting a site-wide look and feel. Try to conform to this structure as much as possible. However, if you can't, these settings can be overridden via the project descriptor. Here you can see source main Java application and library sources. Here you can see source main resources. This is application or library resources. Here you can see source main filters, resource filter files, and you can see source main web application sources, and here you can see source test Java test resource test sources, source test resources, test resources, and source test filters, test resource filter files. Here you can see source IT integration test, primarily for plugins, source assembly descriptors, source site, and you can see and top level you can see you can find license.txt, project license, notice.txt, notices and attributions required by library and that the project depends on, readme.txt projects readme. At the top level, files descriptive of the project, a pom.xml file. Basically, at the top level, the file descriptive of the project, a pom.xml file. In addition, there are textual documents meant for the user to be able to read immediately on receiving the source. Readme.txt, license.txt, etc. There are two subdirectories of the structure, src and target. The only other directories would be expected here are metadata like cvs.git or .svn and any subprojects in multi-project build, each of which would be laid out as here. As previous directories for metadata. The target directory is used to house all output of the build. The src directory contains all of the source material for building the project. Its site, project, its site, and so on. It contains a subdirectory for each type. Main for the main build artifact, test for the unit test code and resources, site, and so on. Within artifact producing source directories, main, that is main and test. For the main, there is one directory for the language Java, under which normal package hierarchy exists, and one for resources. The structure which is copied to the target class path given the default resource definition. If there are other contributing sources to the artifact build, they would be under other subdirectories. For example, source main ANTLR would contain ANTLR grammar definition files. Here you can see a directory layout, project folder, then source and target. Then it's under source there are main, test, IT, and assembly and site. Under main there are Java resources, a web app config, script, and filters here in this diagram. Under test, Java resources and filters here. Here you can see Maven life cycles and paces. Dark ones are the frequently used. Here you can see the all build paces of the default, clean, and site life cycles, which are executed in the order given up to the point of the one is specified. Here you can see clean life cycle. pre-clean, execute processes needed prior to the actual process cleaning. Clean paste, remove all files generated by the previous build. Post clean, execute processes needed to finalize the project cleaning. Here you can see default life cycle. Here you can see validate the project is correct and all necessary information is available. Here you can see the pace initialize build state. For example, set properties or create directories. Here you can see generate sources. Generate any source code for inclusion in compilation. Paste process sources. Process the source code, for example, to filter any values. Generate resources for inclusion in the package. Process resources, copy and process the resources into the destination directory ready for packaging. Compile the source code of the project. Paste here the process classes. Post process the generated files from compilation, for example, to do bytecode enhancement on Java classes. Generate test sources. Generate any test source code for inclusion in compilation. Process test sources. Process the test source code, for example, to filter any values. Generate test resources. Create resources for testing. Process test resources. Copy and process the resources into the test destination directory. Here you can see process test classes. In this diagram, one process is missing, is called test compile after test process test resources. In test compile the test source code into the test destination directory. Then process test classes. Post process the generated text generated file from the test compilation. For example, to do bytecode enhancement on Java classes, the paste test, run test using a suitable unit testing framework. These tests should not require the code be packaged or deployed. Prepare package. Perform any operations necessary to prepare a package before the actual packaging. This is often result in an unpacked processed version of the package. Take the compile code and package it in its distributable format, such as a jar. Pre-integration test. Perform actions required before integration tests are executed. This may involve things such as setting up the required environment. Integration test. Process and deploy the package if necessary into an environment where integration tests can be run. And There's another pace called post integration test. It's not shown here. Perform actions required after integration test have been executed. This may include cleaning up the environment, and then verify. Run any checks to verify the package is valid and meets quality criteria. Then install the package into the local repository for use as a dependency in other projects locally. Deploy done in an integration or release environment copies the final package to the remote repository for sharing with other developers and projects. Here site life cycle. The paces are here, and pre-site execute processes needed prior to the actual project site generation. Generate the project site documentation here, site, and post site execute processes needed to finalize the site generation and to prepare for site deployment. Site deploy the generated site documentation to the specified web server, and here you can see the paces. So here you can see in clean lifecycle, pre-clean is connected to clean, and clean is connected to post-clean. In default lifecycle, validate is connected to initialize is connected to generate resources, and it is connected to process resources, and it is connected to generate initialize is connected to generate sources. Generate sources is connected to process sources. And process sources is connected to generate resources. Generate resources is connected to process resources. Process resources is connected to compile. Compile is connected to process classes. Process classes is connected to generate test resources. Generate test resources is connected to process test resources. Process test resources is connected to generate test. Process classes is connected to generate test sources. Generate test sources is connected to process test sources. Process test sources is connected to generate test resources. Generate test resources is connected to process test resources. Process test resources is connected to test compile. It's not shown here. Test compile is connected to process test classes. Process test classes is connected to test. Test is connected to prepare package. Prepare package is connected to package. Package is connected to pre-integration test. Pre-integration test is connected to integration test. Integration test is connected to post-integration test, not shown here. And post-integration test is connected to verify. Verify is connected to install, and install is connected to deploy. In site lifecycle, pre-site is connected to site, and site is connected to post-site, and post-site is connected to site deploy. As an example, we can consider this one, Maven clean deploy. In a build environment, use this command to cleanly build and deploy artifact into the shared repository. Here the pace clean remove all files generated by the previous build, and in the pace deploy done in an integration or release environment copies final package to the remote repository for sharing with other developers and projects. As an example 2, we can consider this one, Maven compile :test compile. This is compile is plugin, and this is the goal, and this is called the pace test compile. This compile the test source code into the test destination directory. Here uh, this is regarding packaging. The first and most common way is to set the packaging for your project via equally named POM element packaging. Some of the valid packaging values are Java, EAR, and POM. If no packaging value has been specified, it will default to jar. Each packaging contains a list of goals to bind up to a particular page. Here we are considering the default to jar. As an example 3, we can consider this one, configure plugins. The second way to add goals to pages is to configure plugins with your project. Plugins are artifacts that provide goals to Maven. Furthermore, a plugin may have one or more goals wherein each goal represents a capability of that plugin. For example, compiler plugin has two goals, compile and test compile. The former compiles the source code of your main code, while the latter compiles the source code of your test code. Goals that are configured will be added to the goals already bound to the lifecycle from the packaging selected. If more than one goal is bound to a particular page, the order is used is those from the packaging are executed first, followed by those configured in the POM. Note that you can use executions element to gain more control over the order of particular goals. For example, here the Modelo plugin binds by default its goal Modelo Java to the generate sources page. Note that the Modelo Java goals generate Java source codes. So to use Modelo plugin and have it generate sources from the model and incorporate that that into build, you would add the following this to your POM in the plugin section of build. You might be wondering why executions element is there. That is so that you can run the same goal multiple times with different configurations if needed. Separate executions can also be given an ID so that during inheritance or application phases during inheritance or the application of profiles, you can control whether goal configuration is merged or turned into an additional execution. When multiple executions are given that match a particular phase, they are executed in the order specified in the POM with inherited execution running first. As an example 4, we can consider this code segment related to profile activation. This is in file settings.xml. Profiles can be explicitly specified using stroke dash p command line flag. This flag is followed by a comma delimited list of profile IDs to use. Profiles specified in the option are activated in addition to any profiles which are activated by their activation configuration or the activation profiles section in settings.xml. From Maven 4 onward, Maven will refuse to activate or deactivate a profile that cannot be resolved. To prevent this, prefix the profile identifier with an question mark, making it as optional. Here you can see the command here. Profiles can be activated in the Maven settings via the activate profiles section. This section takes a list of active profile elements, each containing a profile ID inside. Profiles listed in active profiles tag would be activated by default every time a project uses it. Here there are two examples of POMs share a common dependency and each has non-trivial dependency. This information can be put in a parent POM like this. This is the parent POM. The dependency management section is a mechanism for centralizing dependency information. When you have a set of projects that inherits from a common parent, it is possible to put all information about the dependency in a common POM and have simpler references to the artifacts in the child POMs. So you can see here group ID A, and here excluding C, exclusion C, and here group ID C, and here group ID A. So this is the parent POM. As an exception example, we can consider this one occurred in environment with Sonar scanner for Maven. Here you can see scanning pro project and etc. And here you can see Apache org.apache.maven.exception, default exception handler, get message here, and etc. As an error example, you can see here build failure and fail to execute goal org.apache.maven.plugins Maven archetype plugin 2.1 generate default CLI on project standalone POM directory. My app already exists. Please run from clean directory, etc. Here as an additional example, we can consider Maven OPTS, Maven underscore OPTS environment variable. This variable contains parameters used to start up JVM running Maven and can be used to supply additional options to it. For example, JVM memory settings could be defined with the value -xms 256M and dash XMS 512M. Now we are considering package org.apache.maven.api. Yeah. Now we are considering the class default Maven in package org.apache.maven. With here you can see the we are considering CLI Maven CLI options reference. You can see the option dash aim or dash also dash make. If a project list is specified, also build project required by the list. Now we are considering running the core ITs in Maven core ITs. By default, the project just packages the test in an artifact. To actually run them, activate the run dash its. This will subject the Maven version running the build to the integration tests. If you would like to test the different Maven distribution, you can also use the Maven home system property to specify the path of the Maven distribution to test, like here. Alternatively, you can just specify the version of the previously installed or deployed Maven distribution, which will be downloaded, unpacked and tested, unpacked and tested. To run it, IT is using embedded Maven 3.x. Additionally, activate the embedded profile. ITs that don't require to fork Maven can also run from the IDs using Maven project from the workspace if the Maven dependencies are added to the test class path. If you are behind a proxy, use the system property proxy.host or proxy.port, proxy.user, proxy.pass and proxy.nonproxyhost to specify the required proxy setup for the ITs. Alternatively, set the system property maven.it.central to a URL of a local repository manager, anonymous authentication only, that proxies the required artifacts. Now we are considering artifact types. Here the archetype artifact IDs Maven archetype the archetype to generate a sample archetype. Here you can see the maintained by the Maven project in available extensions. Here you can see the extension build cache. It's a Maven incremental build and cache, local and remote. Here the version we are considering version 1.0.0. The open source in outside Maven land, the extension notifier, a status notification will be sent at the end of the Maven build. Now we are considering available plugins. There are built and reporting plugins. Maven is at its heart the plugin execution framework. All work is done by plugins looking at for a specific goal to execute. Build plugins will be executed during the build and they should be configured in the build element from the POM. The reporting plugins will be executed during the site generation, and they should be configured in the reporting element from the POM, because the result of reporting plugin as is part of generator site. Reporting plugin should be both internationalized and localized. You can read more about localization of the Maven plugins and how you can help. Now we are considering core plugins in supported by Maven project in available plugins. Here you can see plugin clean up after the build. With regarding the API, the field public static final lifecycle phase clean in enum lifecycle phase in package.apache.maven.api.plugin.annotations. Now we are considering retired. Here the plugin and generate and build file for the project. This is type in the type build, and the version 2.10. Outside the Maven land, here the at Mojo host, formerly known as codehost.org, the plugin here the animal sniffer build signatures of APIs, JDK for example, and check your classes against them. Now we are considering creating and submitting a patch in developing Maven in the Maven Developer Center. We have a couple of guidelines when submitting contributions. The most convenient way to create a GitHub fork from the Git repository you are working with. When you have either completed or issued or just want to some feedback on the work you have done, create a pull request. We have a couple of guidelines when submitting contributions. Verify the status of the master branch on Maven CI. If it is not success, then first try to figure out the problem. Don't start with your own issue yet. You can use the Git bisect to figure out the problematic commit and help with committer to solve the problem. Create your branch from master, not from the tag. Otherwise your patch is outdated the moment you create it and might not be applicable to the development head. If this was a new piece of work without a Jira issue, create a Jira issue for it now. Name the branch after the issue number. Branch name would start with Jira project ID ticket ID. Push your branch with the commit to your fork. Create a pull request to submit to a contribution. Shortly after, someone will review the pull request and give you a feedback on it. A short note: make sure that you follow our code style. Now we are considering why would I want to build Maven in building Maven. Building Maven or a plugin or any component yourself is for one of two reasons: to try out a bleeding edge feature or bug fix. Issues can be found in Jira. To fix a problem you are having and submit a patch to the developers team. Now we are considering checking out the sources. All of the source code for Maven and its related libraries are managed in the ASF source code repositories. For details, see HTTPS this address. Now we are considering building Maven. The building a Maven plugin, no component in building Maven. Building a Maven plugin, no component is like any Maven build, like here. Running integration test before submitting a patch. It is advised to run the integration test, which are available in in the run its run-its, then install. Now we are considering building Maven core. Until Maven 3.3, the Maven core build could be bootstrapped with the Ant build. This bootstrap has been removed in Maven 3.5. You need pre-built Maven to build the Maven from source. To do this, run the source directory here. The assembles will be created in Apache Maven, Apache-Maven, and can be manually unzipped to the location where you would like to the resulting Maven installed. If you want to have resulting Maven directly copied to a directory, you can use the distribution target dir property here. Running the full Maven core integration test before checking in a change or submitting a patch to Maven core, it is required to run the core integration test using your local build of Maven. Run this one here, this command. Now we are considering enable Apache servers in introduction in committers and resources. You need to tell the Maven what your Apache username is. The Maven uses several servers configuration to deploy snapshots and releases on the Apache servers. You need to tell the Maven what your Apache username is. It is highly recommended to use Maven's password encryption capabilities for your passwords. To publish a snapshot of some part of Maven, your Apache LDAP username, your Apache LDAP password. To stage a release of some parts of Maven, your Apache LDAP username, your Apache LDAP password. Now we are considering developers conventions. XML code style in XML in developers conventions. The Maven style for XML file is mainly mainly indentation. Always use 2 spaces indents unless you are wrapping a new XML tags line, in which your case you should indent 4 spaces. Line breaks, always use new line with indentation for complex XML types and no line breaks for simple types. Always use a new line to separate XML sections, so blocks, for instance. In some cases, adding comments could improve the readability of blocks, for instance, or here. Here you can see a workflow, the workflow in Maven JIT convention. Workflow for SVN fork is something like here, and more quiet workflow is like here. Fails because someone else has already pushed to master. So fails because the someone else has already pushed to master, and this creates some mergers. Fails, someone else has already pushed to master. This moves origin / master, and this reapplies your local changes on top of the origin / master. Here you can see introduction in making releases. Here the gpg -- gen key here. gpg -- gen -key. Now we are considering other resources, for example, ASF development infrastructure information. Now we are considering downloading Apache Maven 3.9.4 in Maven User Center. Here you can see the system requirements. The Java development kit Maven 3.9 plus requires JDK 8 or above to execute. It still allows you to build against 1.3 and other JDK versions by using toolchains. Memory, no minimum requirements. Disk, approximately 10 MB is required for the Maven installation itself. In addition to that, disk space will be used for local Maven repository. Size of your local repository will vary depending on usage, but expect at least 500 MB. Operating system, no minimum requirement. Startup scripts are included as shell script tested on many earlier Unix flavors and Windows batch files. Now we are considering installation in Maven in 5 minutes. After that, type the following in a terminal or in a command prompt. The Maven is a Java tool, so you must have Java installed in order to proceed. First download the Maven and follow the installation instructions. After that, type follow this command in a terminal or in a command prompt. It should print out your installed version of Maven, for example here. Depending upon your network setup, you may require extra configuration. If you are using Windows, you should look the Windows prerequest to ensure that you are prepared to use Maven on Windows. Now we are considering how do I make my first Maven project in Maven Getting Started Guide. On to creating your first project, in order to create the simplest of Maven project, execute this command from the command line. We are going to jump headlong into creating first Maven project. To create our first Maven project, we are going to use a Maven's archetype mechanism. An archetype is defined as an original pattern or model from which all other things of the same kind are made. In Maven, the archetype is a template of a project which is combined with some user input to produce a working Maven project. That has been tailored to users' requirements. We are going to show you how the archetype mechanism work now, but if you would like to know more about archetype, please refer to our introduction to archetype. On to creating your first project. In order to create the simplest of Maven project, execute the following from the command line. Once you have executed this command, you will notice a few things have happened. First, you will notice a directory named my app has been created for a has been created for a new project. and this directory contains the file name pom.xml that should look like this. Pom.xml contains the project object model for this project, and the POM is the basic unit of work in Maven. This is important to remember because the Maven is inherently project centric in that everything revolves around the notion of a project. In short, the POM contains every important piece of information about a project and is essentially one-stop shopping for finding anything related to a project. Understanding POM is important, and new users are encouraged to refer introduction to POM in the user manual in documentation. This is very simple POM, but still displays a key element every POM contains. So let's walk through each of them to familiarize you with the POM essentials. The project, this is a top level element in all Maven pom.xml files. Model version, this element indicates that version of the object model this POM is using. POM version of model itself changes very frequently, but it is mandatory in order to ensure stability of use if and when the Maven developers seem it necessary to change the model. Group ID, this element indicates the unique identifier of the organization or group that created the project. The group ID is one of the key identifiers of a project and is typically based on the fully qualified domain name of your organization. For example, log.apache.maven plugins is the designed group ID for Maven plugins. Artifact ID, this element indicates the unique base name of the primary artifact being generated by this project. The primary artifact for a project is typically a jar file. Secondary artifact is like bundles also use the artifact as part of their final name. Typical artifact produced by Maven would have the form artifact, version, and the extension. For example, myapp-1.0 .jar. Version, this element indicates the version of the artifact generated by the project. Maven goes a long way to help you with the version management, and you will often see the snapshot designer designator in the version, which indicate that the project is in a state of development. Name, this element indicates the display name used for the project. This is often used to Maven's generated documentation. URL, this element indicates where the project site can be found. This is often used Maven's generated documentation. Properties, this element contains value placeholders accessible anywhere within the POM. Here the name. Name, this element indicates the display name used for the project. Here, this is often used in Maven generated documentation. And URL, this element indicates where the project site can be found. This is often used in Maven generated documentation. Properties, this element contains value placeholders accessible anywhere within the POM. And the dependencies, this element's children list dependencies. The cornerstone of POM. Build, this element handles things like declaring your project's directory structure and managing plugins. For complete reference of what elements are available for use, POM page refer to our POM reference in documentation. Let's go back to the project at hand. After archetype generation of your first project, you will also notice that following directory structure has been created. As you can see, the project created from the archetype has a POM, a source tree for your application sources, and source tree for your test sources. This is the standard layout for Maven project. Application sources reside in base $sign base directory /source /main /java, and test sources sign base directory /source /test /java, where base direct $sign base open curly brace dir close curly brace represent the directory containing pom.xml. If you are creating Maven project by hand, this is the directory structure that we recommend using. This is the Maven convention. To learn more about it, you can read the documentation. And now that we have POM, some application sources and some test sources, you are probably asking. Now we are considering request a new Jira account and submit an issue in getting help. This is so what we can communicate with you while we work together on the issue. Requesting a Jira account is preferred if you are planning to contribute the project by coding or testing by longer time. This is so that we can communicate with you while we work together on the issue. Please use your real name and the surname if possible in public name field. Links to your public projects, social and professional profile can be appreciated. You can also tell us a little about yourself and what you intend to use this account for. Such information is useful to verify that account is requested for real user, not a bot. Now we are considering what is a plugin in introduction to Maven plugin development in Plugin Developer Center. The Maven Clean plugin is responsible for removing the target directory of a Maven project. Maven is really just a core framework for collection of Maven plugins. In other words, Maven's plugins are much of the real action is performed. Plugins are used to create jar files, create var files, compile code, test unit code, create product documentation, and on and on. Almost any action that you think of performing on a project is implemented as a Maven plugin. Plugins are central feature of Maven that allow for reuse of common build logic across multiple projects. They do this by executing an action, that is creating a var file or compiling unit test. In the context of a plugin description, the project object model POM plugin behavior can be customized to a set of unique parameters which are exposed by a description of each plugin goal or module. One of the simplest plugins in Maven is a clean plugin. Maven clean plugin is responsible for removing the target directory of a Maven project. When you run Maven clean, Maven execute the clean goal as defined in the clean plugin, and the target directory is removed. The clean plugin defines a parameter which can be used to customize plugin behavior. This parameter is called output directory, and it defaults to $project open curly brace project.build.directory closing curly brace. Here you can, we are considering your first Mojo in your first plugin in your guide to developing Java plugins. A simple Mojo, it is a simple Mojo, and this is about a simple. This is about as simple as Mojo can be, and after the listing is a description of various parts of the source. Sorry, I'm going to provide some description of the various parts of the source. This class abstract Mojo in Apache Ogdo Apache Maven plugin. Abstract class to provide most of the infrastructure required to implement a Mojo except for execute method. The listed here is a simple Mojo class which has no parameters. This is about as simple as Mojo can be, and after listing the class Apache, here the class up ogdo.apache.maven.plugin.abstract Mojo provides most of the infrastructure required to implement a Mojo except for the execute method. The annotation at Mojo is required and control how and when the Mojo is executed. The execute method can throw org.apache.maven.plugin.mojo execution exception if a problem occurs. Throwing in this exception causes build failure message to be displayed. The getLog method defined in abstract Mojo returns the log-like logger object which allows plugin to create messages at levels of debug, info, worm, and error. This logger is the accepted means to display information to the user. Please have a look at the section, look at the documentation for more information. All Mojo annotations are described in Mojo API specification. Here says hi to the user. Now we are considering how it works in introduction. A regular Maven project usually invokes the reporting goals of a plugin by declaring such plugin in the reporting section of the pom.xml as in this example here. When Maven site plugin is invoked, for example Maven site command, the specified plugins are loaded and generate the method of each merger class that implements Maven report is executed. The generate method generates a document through the Maven Doxia sync API. This document is comprised of basic elements like title, heading, text, links, label, etc. This is where you will put the logic of your report assembling element based on the content of the Maven project. This document elements are passed to Doxia to generate HTML document, which itself gets wrapped into a Maven skin as specified in the projects ./source/site/site.xml. The result produces an HTML file in the ./target/site directory of your project. Here you can see unit tests. Here you can see Maven plugin testing harness in unit testing your plugin. The abstract, you can see the class abstract Mojo test case in package ogdo apache.maven.plugin.testing. The Maven plugin testing harness is explicitly intended to test the ogdo apache.maven.reporting.abstract Maven report execute implementation. In general, you need to include Maven plugin testing harness as a dependency and create a Mojo test. By convention, the class extend the abstract Mojo test case. required for Mojo lookups to work. Sorry, here. Here you can see verify plugin documentation in documenting your plugin. The Maven docck plugin can be run here. The Maven docck plugin checks that the project compiles with the plugin documentation standard. You should verify that all plugin documentation respects this standard. The Maven docck plugin can be run here. Now we are considering introduction in the Mojo API. Although the requirements on Mojos are minimal by design, there are still very few requirements that Mojo developers must keep in mind. Maven plugins can be written in Java. These are the things, and the Maven plugin can be written in Java or any other number of scripting languages. Plugin consists of one or more Mojos, each one being the implementation for one of the plugin goals. Note this document plugin goals. Although the requirement on Mojos are minimal by design, there are still very few requirements that Mojo developers must keep in mind. A Mojo can have a method named execute which declares no parameters and has a void return type. If this method throws an exception, that exception must either be a derivative of java.lang runtime exception or a derivative of apache.maven.plugin.mojo execution exception. It goes without saying that in the letter case, the execute method must declare that it throws this exception. Additionally, Mojos must declare a field for each goal parameter they specify, and these parameter fields will be populated before execute method is called. Finally, all Mojos must be accompanied by metadata in meta info maven plugin.xml describing parameters, lifecycle bindings, etc. This descriptor will be covered in more. You can get more information on these descriptors in documentation. Now we are considering configuring logging in Maven 3.1.x logging. Every entry in this file can be overridden via Maven's JVM system properties by using the -d flag in Maven_opts, for example. To configure the logging with SLF4J simple, you can edit the properties in the $maven.home /config/logging simple logger.properties file. Please see the link reference of documentation for details. Every entry in the file can be overwritten via Maven's JVM system properties by using the -d flag in -d flag in Maven options here. For example, here you can see this Maven this one thread name equal true, and Maven goals will add the thread name to every logging line. This will add the thread name to every login line, and this will add the logger name to every login line. The default SL4J configuration for Maven is listed in the documentation, where you can see other useful property names to customize logging. Now we are considering build your extension in Maven 3 lifecycle extensions. Here, the create your extension class. Your extension must be a Sisu component. therefore mark it with the JSR 330 for all legacy plexus container annotation. Here the class abstract Maven lifecycle participant in Octopus Maven allows core extension to participate in the Maven build session. Session lifecycle and allow all build will pass before XXX and after XXX naming pattern to indicate what at what lifecycle point it is being called. Here the and after here. To create Maven project with dependency on org.apache.maven colon maven dash core colon 3.9.4 and other dependencies. Here the Maven core here. Create your own extension class. Your extension must be a Sisu component. Therefore mark it with JSR 330 or legacy plexus container annotation. Generate Sisu index files during the build of your extension jar. Always provided by the Maven core class loader. Dependency for the JSR 330 annotation. Always provided by the Maven core class loader. Start BA machine. Ask beer to the machine. Here you can see the receipt for in how to upgrade the Plexus Java doc text to Plexus Java annotations. In your pom.xml, add the Plexus component annotations dependency. In your pom.xml, add the Plexus component annotations dependency. In your Java sources, replace Java doc tags with corresponding here the corresponding Java 5 annotations. Now we are considering how to use JSR 330 in plugins in using JSR 330 instead of Plexus Java annotations. Constructor injection. With the Plexus Flex greatly simplified the testing. Let's take a look at an example plugin. If you want to look at this example project, you can find it in the Maven core ITs. The POM is a setup for 300 JSR 300 300 with the java.inject dependency and java.index dependency and the Sisu Maven plugin. Configured to create JSR 330 component index. In addition, we added the classical Maven plugin dependencies, Maven plugin API, and Maven plugin annotations to extend abstract mojo, and use Java plugin test tools annotations associated with Java plugin plugin. Now let's look at the plugin code. You will notice that that were using constructor injection, which makes testing a lot easier. If you want to test your JSR 330 component, you do not need the container to instantiate the mojo. In this simple case, you can actually test the plugin without using plugin testing harness, because you can instantiate JSR 330 component and JSR 330 mojo directly and wire everything up manually using constructor. Constructor injection with Plexus lacks greatly simplified testing. Say hello to the world, my little constructor injected component. Here you can see a basic sample in Maven repository, the package with the API, with the API, we can consider the method at not null public model.builder repositories collection type parameter repositories in class model.builder in package apache.maven.api.model. Not recommended, this part. Now we are considering digging into central index with look in central index. Download and extract the look binary table and launch it on the central index with Lucene format. First, download central index nexus Maven repository index.gx, download Maven index.cli, and unpack the index to raw Lucene index directory. Download and extract the binary table and launch it on the central index with Lucene format. You need an old Luke version using old Lucene version, since Maven index 5.5 3.1, users Lucene 3.6.2 for this but with more recent Maven indexer releases, more recent Lucene version have been used. Now we are considering where do I set artifact extension in Maven artifact with type handlers here above here. Maybe surprisingly the dependency to this very same artifact can be described in two ways. Maven POM, where you can declare your project parent project dependencies plugin another, maps those elements into artifact coordinates with some extra logic. Also, this has consider for example the artifact org.project reusable test support 1.0 tests jar with this type handlers. Maybe surpassing the dependency to this very same artifact can be described in two ways. And the equivalent would be equivalent dependency would be here. Obviously different is presence of classifier in the first case, while in the second lack of it, but presence of type test dash jar. In the other hand, implies classifier of test. In both cases, extension is jar. In first, it uses the default value of this property, while the second type is type defined it. Not in this very case. Using the first way is somewhat explicit and is recommended way. Not so far for the cases when type handle carries some important extra information like some custom packaging, where using type is more appropriate. Simply put in this case, the type test dash jar is like an alias for ordinary jars with test classifier. Now we are considering the A-level metadata in metadata. The XML bits considered for this kind of metadata are only the artifact level metadata found in directory of artifact serves purpose of version discovery. This metadata contains a list of versions of given GA coordinates, and XML bit considered for this kind of metadata only. Now we are considering Maven repository layout. The layout is responsible for translating the artifact coordinates into generic path, but is later used to construct the some URL, file path URL. It depends on context. Obviously, since Maven inception in 2002, the layout evolved as well. For simplicity, we will cover current layout, also known as Maven 2 or default, as since Maven 3.x release, the deprecated Maven 1 layout, also known as legacy, is not supported anymore. This above implies following: the repository contains a file that is not on layout, does not obey layout transformation rules discussed rules. The file is not addressable by the Maven coordinates. You cannot address that file in Maven, nor make it to download it using gav coordinates. Using some properties transformed, we can construct the following path if classifier is not present, like here. Or if classifier is present, you can use this path. So the example artifact can be noted as gav GAV, and is translated to path as like here. and that is it. This applies to this algorithm, and above any artifact can be built up path segment that artifact is expected to be. Important note in this case, in case of locally installed artifact, those you built locally and invoked Maven install will use artifact based version property instead of version. The full-blown timestamp version are used by in remote repositories when the artifact is deployed. So this is the full tar file. Now this is the end of my presentation. Thank you very much for watching it.